Hi, this is Nilton, and thank you so much for considering taking the JUnit 5 course for complete beginners. I am Nilton. I've got over 20 years of experience as a senior Java developer. My background is C, C++, and many other languages for the JVM and otherwise. And I've been using JUnit 4 and JUnit 5 for quite a few years now. What we will be covering in this course is the fundamental concepts related to unit testing, state-based testing in particular, and then what are the features that JUnit supports. We're going to be covering JUnit 4 features first, primarily because there is a lot of code base out there that still uses JUnit 4, and then we're going to be moving to JUnit 5 features. So you're going to, if you complete this course, you're going to be, I'm going to take you from a complete beginner in unit testing in general and JUnit in particular, from complete beginner all the way to an advanced user of JUnit. Please consider taking this course. My advice to you is practice. I'm going to provide the link to all of the sources onto GitHub. Don't just sit around watching video lectures like you're watching an episode of Game of Thrones or something. If you do that, you are not going to learn much. I'm going to be providing a project where the idea is for you to apply all of the concepts that you learn in the course to apply in this project. Again, I highly recommend that you complete this project, and at the end of the course, if you find it that you learn something, please give it a positive rating. This will help with the ranking, as well as leave comments on things that I should improve in the future. This course is not static, it's not like a book. It's a dynamic product, so I will be updating it as I get positive feedback. Again, thank you so much for considering taking the JUnit 5 complete course for beginners. I am Nilton. Ciao! Hi, this is Nilton from craftofprogramming.com, and today we're going to talk about unit testing. So I've got here in the board a map of the topics that we are going to cover in this lesson, and we're going to be defining what a unit test is. What are the properties or features of good unit tests? What are the types of unit tests that you are going to implement, as well as the mechanics of how unit tests are implemented. So let's start with the very basic question of what a unit test is. So unit test is essentially a small piece of code that applies an input onto a component and then asserts or verifies the expectations that you set. So typically a component is referred to as CUT, or component under test, and essentially what you do is you have this component under test, which is essentially at the level of granularity of unit test, is a class or a very small group of classes which are very related to each other. And this system, you apply an input, and then this input moves this class from state Y to state Z, and it produces an output. And essentially what you do with with a unit test is you assert that this system is on state Z. So that's essentially what you do. So basically, the properties of good unit tests is they need to run fast, and fast typically means milliseconds. Now, why is it important that unit tests need to run fast? Well, primarily because of scale. So on a realistic code base, typically you'll find that there are tens of thousands or more of unit tests that are run, and these usually are run on basically triggered by a commit on a on say master branch or develop branch. And every time you do that, the build kicks off, and as part of your build, you run all your tests. So it's important that these tests run fast so that your whole overall, test suite of tens of thousands of tests run, fast. Another reason why unit tests need to run fast is because of you want to have quick feedback loops while you are implementing code. So if your tests run slow, then you're not gonna be compelled to use them while you are coding. You want to have quick feedback loops where you implement something and then you run your tests, typically to make sure that, if you are adding a new feature, that you're not breaking any existing tests. So it's important that you have this quick feedback loop that gives you confidence that you're not breaking anything as you are developing a feature. So again, tests that run fast, you're going to be encouraged to run them often as you develop, features. So another good property of unit tests is that they need to be small and focused, right? Typically a test is a method, and they should test only one single piece of production code logic. And one good heuristics to check that tests are small and focused is that they should not have any control, flow statements like ifs or elses or whiles or loops. If you start seeing the need to implement these in your single test methods, then this is a sign of bad practice. It's a smell, and at that point you need to be thinking about breaking this method into multiple individual tests. Another good property of unit tests is trustworthy. And what I mean by trustworthy is that the developers in your team need to trust the tests. And one metrics for that is that tests should not produce false positives nor false negatives. Now, false positive is essentially a test that basically has an assertion failure for for production code that is working. This assertion failure is a problem of the test, not of the production code. Conversely, a false negative is when a test fails to detect an actual bug on production code. So as you can imagine, either of these things are bad for a test or a test suite, and if this starts happening with frequency, then what's going to happen is people start lose trust on the tests, and then they will probably just add the infamous @ignore annotation to the test, and because they just don't trust them. Another important things to a test is readability, which is closely related to maintainability of a test. And essentially here, what you should really pay attention to is observe good object-oriented practices when writing tests. So all of the good object-oriented practices, and idioms that you apply when writing good object-oriented code in production, you should observe them while writing unit tests, because after all, unit tests are, source code. And just like production code, unit tests evolve and change over time. So the production code that the unit tests are testing evolves and changes, and so does the unit test. So it's important that unit tests are readable and maintainable. So don't forget that these things last for a long time. The original developer may have left the team. So it's important that any new developer that looks at a test understands it quickly what it does, and it's able to extend it or to make changes to it. Another important feature of unit tests is automation. So for that, so automation here is basically two levels. One is at the level of IDE while you are working locally, and obviously any modern IDE like IntelliJ IDEA, for which I have gonna put here a link to the IntelliJ IDEA tutorial that I have a course on that. So any modern IDE, be it IntelliJ IDEA or Eclipse or NetBeans, they have full support to run unit tests. And automation is also at the level of continuous integration systems like TeamCity or Jenkins. And here, it's important that the unit tests are integrated with your builds so that every time you do a commit, it triggers a build and your tests are run. And the support for all of these is obviously through frameworks. So another thing that I'd like to cover is types of unit tests. So basically, they are split into state-based tests and interaction-based tests. And what are the difference between these two? Well, state-based tests, you can think of them as results-driven tests or black box tests. This is typically what you test in, the NUnit family of tests, be it, for example, JUnit. And that's basically what this is, right? You apply an input onto the system or the component under test, and at the end, you assert that the component has moved from state Y to state Z as a result of your input. So you don't care how it got to that state. That's why it's results-driven test. So this is basically state-based test, and that's what JUnit typically supports. Conversely, an interaction-based test, some people call it action-driven test, and think of it as a white box test. And typically, what you are interested here is, you have your object here, and this object basically exchanges messages with its collaborators. Like say, object Y sends a message to object Y. This guy sends a message to object X. It sends a message, so let's say message F, and then you get another message, G. There is another message here from another object, Z, that sends a message to this, H. So essentially what you are testing here is the interaction or the exchange of messages from your object with its collaborators, like object Y here, object X, object Z. So that's why I call it a white box test. You are actually checking what messages were exchanged between the object under test with its collaborators. And this typically, you can go to the level of which parameter actually got, was transmitted with that message. You can make assertions at that level. And this typically is supported by mocking frameworks. For example, Mockito or EasyMock or TestNG in the Java ecosystem. But for JUnit is really focused on state-based test or results-driven test. So now we've covered what unit tests are, properties of good unit tests, as well as types of unit tests. Now, how do you go about, implementing these? What is the support that you have for unit tests in the Java world? So this is basically done, obviously, with JUnit, framework. So for this course, we're going to focus on JUnit 4 and JUnit 5. I will start with covering JUnit 4, even though JUnit 5, as of March 2019, when I'm recording this, is already released. But the reason why I want to cover JUnit 4 as well is because there is a lot of code base out there that is using JUnit 4. So, the odds that you are going to join a project that is using JUnit 4 is just too high. So it's important to be familiar with JUnit 4, and obviously we're going to cover, the new features of JUnit 5 as well. So what I have here is the mechanic or the anatomy of a, JUnit test. So essentially the tests are, marked or tagged with a run with. So that's the basic JUnit runner. And the class under test itself typically has a before class annotation, an after class annotation, and then before, after, and tests. So the before class annotation is applied to a public static void method, and this is run once when the class is loaded. So you load the class under test, and this method is run. Conversely, the after class annotation is must be applied to a public static void method. The name of the methods, incidentally, don't really matter. What matters is that the modifiers, the before class annotation needs to be applied to public static void method, as well as the after class annotations. But like I was saying, the before class is applied to a method that is executed only once when the class is loaded, and the after class annotation is applied to a method that is invoked after all of the tests in a class under test are run, including the teardown method. So before class and after class, you would use them to do, static initialization of state that you would need before all the tests in a class under test, and for the after class, all of the cleanup that you need to do once. Before and after annotations are applied to instance methods, public void instance methods. Again, the name don't really matter. By convention and for historical reasons, they are called setup and teardown respectively. And these two methods are called before and after each of the test methods respectively. So a test method is tagged with the test annotation, and again, a test method needs to be a public void method. Again, the name doesn't really matter. And before each of the methods, the test methods which are annotated with the test annotation are run, the method setup is run, and then after the test method successfully finishes, the method teardown, which is annotated with the after annotation, is run. So actually, that reminds me of one important thing that I didn't mention here of good properties. Another good characteristic of a test is that they should be isolated. What do I mean by that? What I mean by that is that the state that basically the state after a test terminates needs to be the same as the state before the test terminates. So obviously, if a test typically modifies the state, so you need to make sure that the state is restored to the state before the test ran. And this is what you would do with the before and after methods. So there should not be any dependencies on the order, for example, that you execute tests. This is a sign of that the tests are not isolated, that there are interdependencies between the tests. So to fix that, you need to make sure that, like I said, after a test finishes, you need to restore the state to the way it was before. And this is why you'd use the before and after methods. So I think that's pretty much it as an overview of what we are going to be covering. So we're going to be now that we have this good conceptual framework of what a unit test is, what are the properties of good unit tests, what are the types of unit tests, and how they are implemented or supported by frameworks. Now we are in a good position to dive into code and actually get into the details, implementation details, of JUnit. So we're going to go through an example, as realistic as possible, and we're going to be covering all of the features of JUnit 4 as well as JUnit 5. Thanks for watching.
Okay, so now let's look at code as promised, and this is basically the same anatomy of a JUnit test. This is as basic as it gets. So what you would do on you know, the most basic vanilla JUnit test is you would have you know, your test methods, which are annotated with the @test annotation. If you want to temporarily disable a test method, you would annotate them with the @ignore annotation. So in this case, we have 4 test methods. 2 of them are enabled and 2 of them are disabled. The @ignore annotation, you should really not leave this test in production like that. This is just for temporary fixing something. So then you have the before and after methods, and these methods are, as I mentioned, run. The setup method is run before each of the test methods, and the teardown method is run after each of the test methods run. So they will be used to initialize state that the test method needs, and teardown would be to clean up or restore the state to the way it was before the test method ran. This is because, as I mentioned, you want to have isolation between tests. So these two tests should be completely isolated from each other. That is, the state that each test sees in the beginning of its run should not depend on the order of execution or how the output of the previous test. It should be completely, the results should be consistent and the same regardless of the order that these two tests are run. And lastly, the before and the after class annotations, as I mentioned at whiteboard, are used to basically used for methods that you want to execute only once. So for example, you would want if you want to connect to a database, you would put it on the before class, on a method annotated with before class, because it's an expensive operation that you want to do only once. You definitely don't want to do that database connection before each test. It's just going to slow down the test. Remember, one of the properties of the test that I mentioned was they need to run fast. So you would do these kind of things only once. You'd put them on the method annotated before class, and then lastly, before the test is after the test runs, you would then release that database connection. Again, you would put it on the destroy expensive resource method, which is tagged with the after class. So each of these methods, all of these methods are they have just a system out for us to see what exactly happens when I run this this test using the so I'm using the IntelliJ IDE graphical runner. As I mentioned, any modern IDE, IntelliJ IDE, Eclipse, NetBeans have an integrated graphical runner for you to run tests. I'm assuming that you are familiar with IntelliJ IDEA. If not, please refer to, which I'm going to put a link here, a card here, refer to my complete IntelliJ IDEA tutorial course, where I take you from a complete beginner of IntelliJ IDEA all the way to an advanced user. So please refer to that course if you are new to IntelliJ IDEA. So anyway, now that we ran the test, let's see what we get here. So as you see, you can see that the setup and the teardown methods are run before and after the test respectively, right? You see? And also notice that the init method, it's run once, and the destroy is run once at the end. So init is run right at the beginning before even the setup method was run, and then after all, and then you do all the tests. Setup is run, you do the test method, you do the teardown, and then you do the other setup, run the test method and teardown, and then at the end you do the destroy. So this is how fundamentally the life cycle of JUnit in terms of the initialization, setups, and teardowns of resources. Okay. Another thing I want you to see is that the methods that are disabled, with the @ignore annotation, will not run. Okay. So now let's enable these methods by basically adding the test annotation. And what I want to show you is something else, which is that even if the methods fail gracefully or throw an exception, you will see that the setup and teardown methods, particularly the teardown, which is invoked after it, they will still run. Okay, so let's rerun this and see what happens. Okay, notice that this is the method that is throwing an exception. So it's as you can see, this method has an error. Notice that the setup method was invoked, and so was the teardown. Okay, even though we had here an exception. So this test is basically is in error. And the same thing for here. This is an assertion failure. It's a gracefully failure of a test, and the teardown method is still invoked. Okay, so this concludes the very basic introduction to JUnit, where we covered the anatomy of a JUnit test. Thanks for watching. So remember, JUnit is a framework to do state-based testing. So what we're interested in asserting is that after you apply a stimulus or an input to a class under test, that this class is in a particular state. So let's demonstrate here in a very, and along as we do this, I'll show you the assertions. I have here a very simple class, which basically, I don't want to get into much details because it's not really important. This class basically has a list of books, and which are representation of a CSV file, which is here, and basically a book, if you look at the description of a book contains a title, a page count, a topic. A topic could be, it's the genre of the book: computing, sci-fi, novel, finance, and so on. A publication date and a list of the authors, right? So it's a very simple data class. And the only thing that this DO is doing is it's parsing this CSV file, which contains a list of books in CSV form, and it basically just parses this onto a list of these book objects. Okay, and then it does some queries. I don't want to cover this yet. We'll cover this in a more advanced lesson. For now, I just want to go back to the test and show you how we use setup and teardown methods, and how we do very simple primitive and object assertions, which are the fundamental building blocks of JUnit. So in the setup method, you will want to create the the object. So it's going to be a book DAO. And conversely, in the teardown methods, you will want to destroy it. So remember, the idea is that we don't want this state to, to basically be carried over, so to speak, between test runs. So whatever we do on a test, we want to clean up after ourselves. So doing the object initialization in setup method and then nullifying it on the teardown method guarantees that each test basically gets a clean book DAO object, which is what you want. So another thing I want to do with this DAO object is get the library. So first I need to parse the library from a path, a default path where I have this file stored. So I parse this, and then I want to get the library, and I want to assign it to a field. So I'm just going to extract a field called library, and that should be that. Let's just do this here. And also here, obviously, I want to nullify the library field. Okay, good. So this is how you fundamentally do things in JUnit. So setup method, initializes the state or the component under objects. As I said, you may use the the before class method to assist you with that for one-time action, and then the teardown method basically either nullifies or clears the state or what have you, typically in the opposite order that you initialize the resources. So think of it as the constructor or initialize things, and this would be the destructor for each and every method. Okay, so now that we have a library of books, then let's just exemplify by doing some very simple assertions here. So primitive assertion examples. If you look at this test class for JUnit, you will see that assertions basically come. So the most fundamental assertions that you can do is assert false and assert true. Okay, so and one interesting thing or point to note in JUnit is that the assertions basically are overloaded, and they come basically in two flavors. One is one that has just a condition, and another one that has a message. This message is basically the error message that the test would print to standard output or to a log in case of a failure. And this overloading of an assertion method with and without error message, it's consistent all over. Another important thing is the order of the expected and actual methods. Typically, JUnit has the expected method first, the parameter, and the actual is usually the last parameter. And again, you have two variants, one with the message and one without the message. So let's start with the most simple assertions examples first, and then we're going to move to object assertions and array assertions. So the most fundamental way to assert is just the assert true statement, right? And basically, like I said, you have two variants, one with the error message and one without. And for example, for this particular example, library size, I can just say if the size equals to 10, then this should be true. Why? Because the book CSV I know that it is loading 10 books. Okay. So another variant of this assertion is one that takes a message, which is the first parameter, and this message is the error message. So you would use this to report a failure, and you would say size should be 10. I mean, obviously this 10 would be extracted as an expected parameter, but anyway, this is just for the sake of example. And one similar to assert true is obviously assert false. And I could assert that the size, that it's false, that the size is not 10. Okay, so this is the most fundamental way you would assert, and if I run this, then it should pass. Okay, good. So then the other very fundamental way to assert things in JUnit is object equality and identity, and also check for nulls. So you do assert null, right? So that's the most fundamental thing you can do. And for example, I could say that if I use some full string here, full, and I assert to null, then I could assert that that this is true. Assert, then you have the opposite of a certain null, which is assert not null. So we know that this object library is not null. Okay, so this is the basic things you can do with references. Then object equality equals, so this you have primitive equality and you have object equality. So when you do for object equality, this actually will invoke the equals method on the object. So for example, assert that it equals that the library size is 10. That's one thing I can do. So different than assert equals is assert the same, and this is object identity. So this, if I type correctly, library and library are the same object, right? However, assert not the same. If I were to instantiate an object here, new object, then it's true that these two objects are not the same, because the same, remember, tests for object identity. So this here, assert same, is exactly equivalent to assert true that this object is equal to this. Okay? So if I now run this, then everything should pass. Okay? So again, assert true and assert false are the fundamental ways to do assertions in JUnit. You can test for reference types, nullity or equality of objects, and using object identity. Lastly, I'd just like to cover how you would test for arrays equality. So as you can see, this method is heavily overloaded to support all types of primitive arrays as well as object arrays. So let's exemplify with a simple array. So let's say array 1 and array 2, and let's create these guys here. Let's do an int array, and let me just do I don't know, 1, 2, 3, and let me copy this and do a2, and now this should be true. Let's run this. Okay, but for example, if I have another array here, a3, then it has another element or whatever, you get the idea, right? Then this will be false. Okay, array lengths differ, and notice that the message is fairly descriptive. Okay, so this concludes the fundamental assertion types that JUnit supports. On the next video tutorial, we're going to cover advanced JUnit matchers. Thanks for watching. Okay, so in the previous lesson we covered the basic assertions that JUnit 4 provides, particularly assert true, assert false, assert for object equality, assert for arrays, assert for nullity, and so on. So those are basic fundamental assertions that JUnit provides. So what I'm going to cover in this lesson is how you can leverage the Hamcrest matchers to write very expressive tests. So these matchers, as you will see, are some sort of basically syntactic sugar that you utilize in your tests to make them very, very expressive. And that's the whole point of these matchers. So you will need to add a dependency for the Hamcrest matchers. So in terms of the dependencies, JUnit comes packaged with the Hamcrest core. But if you want to extend that, you will need to have the Hamcrest library. Pick any version. I'm using version 1.3, which is the latest stable version as when I record this, March 19. So these are basically the assertions that we covered on the previous lesson, and they come with JUnit 4. And if you look here, Hamcrest core 1.3.char, so these are advanced matchers that we are going to cover in this lesson, and as well as additional matchers that come from the Hamcrest library. Okay, so now that we covered the basics of adding the dependencies to the IDE, let's write some Hamcrest assertions. Let me add a test method. And if you recall, we were writing very simple. For example, we're writing that the library size was equal to 10. And if you recall, the library is nothing but a collection of books, and book is essentially a data object which represents a line here on the CSV. So I'm not going to cover this here, but basically there is this book DA object which parses this book CSV onto a list of these book objects. And the only thing, basically what I was asserting previously, was the size of this list and so on. So So we know it's true that the size of this library of books is 10. That equivalent assertion that we wrote was assert equals that, which is equivalent that the library size, so the actual value is after, so the expected value comes first. It's true that the library size equals 10. So these were two assertions that we wrote, and obviously if I run this, obviously passes. Let's write this test using Hamcrest matches to see how it's much more expressive. So the main assertion that Hamcrest provides is assert that. So I want to assert that the size of the library. Then I'm going to pick the matcher. So core matchers is, and again core matchers equal to 10. Now obviously I'm going to add a static import here to make this thing very, very expressive and readable. So I would argue that this test, which is exactly equivalent to either of these, it's much more expressive. It reads almost like English. Assert that library size is equal to 10. I mean, this is as close as it gets to English. So now if I write this test, then it passes. That's the power of the Hamcrest assertions. It adds a lot of syntactic sugar, it makes your tests readable. And so that's something very basic that we did. If you recall, I also wrote that I use assert not same, that the for example new object, these objects are not the same, and you can write this using the Hamcrest assert that new object not the same instance, and new object. Okay, so that's again equivalent to this, but much more expressive. Assert that this new object is not the same instance as this object. So again, if we run this, then it passes. Moving on with the assertions that we can do with Hamcrest, there is another cool one which we can basically use if we're working with strings, which are so pervasive in Java. There is support for matchers which work with strings. So for example, let's say that I have I'm working with one of the books in my library, like say effective Java, and I want to assert that this title contains a string, for example Java, right? So again, this is something very expressive that you can just write like that, right? So this was a very simple a matcher that is just basically matching. This is just a single matcher. Now one nice thing about these Hamcrest matchers is that you can compose them using Boolean expressions. So let me exemplify here. So let's say that I want to assert that not only that this book contains the string Java, but it actually contains both the effective and the Java string. Okay, so the way to do that, I just basically need to compose or build a matcher that is composed of two contain string matchers. And the way you do it is, so for example, let me get effective Java, and there is this matcher called both, and this matcher basically is composed, accepts a composition of matchers. So contain string Java. So let me just close this, and contains the string effective. Okay. Another way that you could have written this is assert that. Okay, so too much typing here. Let me just duplicate this and assert that the effective Java. So you can do all of, and then you do contains string effective, and contains the string Java. Okay, so now if you run this test method, and everything passes. So these are equivalent. I mean, both is if you are dealing only with two matchers. All of it's basically an end of any matches, right? I could have written here more. All of it is an AND. Okay, so we have introduced some basic matchers for strings. Now let's say that we have a collection, you know, for example, let's get the our DAO, and let's get the book titles. Terminate this, introduce book titles. So now we have these book titles, which is, you know, as the name implies, a collection of the titles of the books in my library. And let's write some more assertions. So I can assert that, for example, let's say I'm trying to determine whether one of the books in my library, you know, he is the effective Java book. Then I'll just assert that the book title as an item, and I can just write the name of the book, effective Java. Okay, so that's a nice one. So I'm asserting that one item in my library is, you know, is effective Java. So to show you how powerful these matchers are in terms of expressiveness, you know, and functionality, let me write the same assertion without using the assert that or has item. So the first thing I need to do is I need to, you know, get the equivalent condition here. So if I get a stream and I say it matches any title that is equal to effective Java, okay, then I can do any match. And now, you know, what I want to do is I want to assert true. Okay, so I mean, obviously I'm leveraging the power of the Java Streams API, but you know, I would argue that it's easy for me to write this than having to write that. And we will see as we write more powerful examples that, you know, it reduces boilerplate. But that's these two things are equivalent, you know. But obviously I wrote less here, and this is more expressive. This is a simple assertion where I'm asserting that one item in my book titles, you know, matches this, so at least one. What if I want to assert more than one? For example, then, you know, there is a matcher here as items, and as items it takes a var arg, so I just pass in a list of books that I am trying to determine that are in my library, like say Design Patterns, which is an awesome book. Okay, I mean, obviously I can compose this even further. I can say that you know, as an item, instead of just saying as an item and just pass the actual parameter, I can compose this as an item that say starts with, for example, the word effective, right? Or as an item that ends with the word Java. So you can you know, compose these things, and my advice, I mean, is that come here to the core matchers and look at all the options that are here. You can if you familiarize yourself with all of these matchers, you can write very, very expressive JUnit tests. Okay, so previously you saw that we used the all of matcher to effectively build an AND of assertions. So similar to all of, there is the assertion any of, which is an OR. So for example, I can write something which is Design Patterns is a great book, and I can use any of matcher, and I can say that I'm matching that any of the strings start with design, and for example, if I get this right, ends with the word book, for example. And you know, you would use this composed matcher to match any string that you would pass here. Okay, so this is matching, this is true if either of this or this is true, because any of is an OR. If you are dealing with just two elements, then you can write this, either this starts this or that ends this, and obviously I could write something different, either it starts with this or, you know, equal to. It doesn't really matter. The point is you can just compose all of these matchers by using Boolean logic. So we've covered the case of any of, which is a OR, we covered the OLOV, which is a matcher of matchers that uses the AND boolean. So for completeness, let me write one that uses the NOT. So then we have all of these matchers that use boolean expressions covered. So let's say I want to match a string that does not contain either the word C++ nor the word Python. Then I will write a matcher which is not any of, I don't want any of. Then I'm matching two strings, contains string, and I said the Python and C++. Okay, so this matcher matches the negation of any string that contains C++ or Python. So this concludes the overview of Hamcrest matchers. I hope you found this video useful. Thanks for watching. Okay, so let's get started. In this lesson, I'm going to cover exception testing in JUnit. And as you can see here, there are basically three fundamental ways of testing exceptions in JUnit. One is using the expected exception. The other one is using the try-catch idiom. And the third option that JUnit supports is an expected exception rule. So we're going to cover these three fundamental options or ways of testing exceptions in JUnit, and we will cover the pros and cons of each of these three options. So I've got here a very simple class, test class, and basically this test is testing a I have here an example which is a class under test, and this class under test is obviously a very simple contrived example, and it's got three methods that throw an NPE on array index out of bounds exception, and there is here a third method that throws also an array index out of bounds exception. Okay, so now let's cover the first option and see what are the pros and cons of this option. So basically what you do with the expected exception is you basically write your test method, and what you do is you tag it with the type of the exception that you are expecting. For example, you can just say I'm expecting an exception, and you put the type here. Okay, so now if you write a method, you execute the method, and you don't and the exception is thrown, then it's gonna fail. So let's run that, and the method has failed because the expected exception was not thrown. So now let's actually throw the exception. So let's throw the exception with some full message. It doesn't really matter, and let's just add the exception to the method signature, and let's run it again, and notice that the method has passed. Okay, so but obviously this is a very it's not specific enough. So let's say that you are interested in testing that a specific subclass, a specific type of exception is thrown. For example, an index out of bounds exception. Okay, let's test this case. So what you do is you would invoke your method. So let's create an instance of, so obviously it's not the DIO that I want. Let me create an instance of my class under test here, and let me assign this guy here. So I've got my class under test, and let me invoke a method. So now let's invoke a method that throws an NPE, for instance. So because I'm invoking a method that throws an NPE, but I'm expecting an index out of bounds exception, then the test should still fail. Okay, so it's failing because you are expecting this exception type to be thrown, but a different exception type was thrown. So obviously now if I invoke the method that throws the expected exception type, then the test should pass. Okay, so this is a very convenient way of testing a method in production code for which you are expecting that a certain exception type is thrown. There are basically two limitations. Firstly, you cannot assert against the message of the exception. So this exception, in this very contrived example, actually has an exception message. And I might be interested in my test method to test that not only the exception of a particular type was thrown, but also that it has a message. So I can't assert on the message. And there is also another limitation of this option of testing exceptions, which is any exceptions thrown here in this method, the test will pass. And this might not be what I'm interested. So for example, let me demonstrate. So again, I have here this under test. And let's assume that I want to assert that this method actually throws the exception. But before that, I'm actually calling some other method here. For example, print the first book title. But there is a problem here. So the problem is that this method, as you can see, also throws an array index out of bounds exception. It's not even gonna get here. One way to test it is just, let's just write something here. Print current class name. Let's just do that. And let's run our test method. Okay, so the test passed because the index out of bounds exception was thrown, but notice that it never got to our method here, which is printing, this message in to standard out. Okay, so the second method or option is using the try-catch idiom. So this is option 2, using the try-catch idiom. So let's add a test method, and this test method, let's just call showcase the exception handling or exception testing using try-catch idiom. So essentially what you do is get your class under test, and you invoke the method that throws the exception, and you surround it with a try-catch block and you catch the exception of the type that you are testing or that you're expecting to be thrown. Okay, so then what you do is you write after the method is thrown, if the exception is not thrown, you write a fail, you add a fail statement. And this fail statement, basically, typically you write a message that mentions that the exception type that you are expecting to be thrown, expect an exception, blah blah blah, to be thrown, and also here you write assert that the message, if you use the core matchers, contains the string array index out of bounds exception. And let's just do a static import here to make this thing more readable and expressive. So that's essentially the idiom that you utilize. So you invoke the method that that you are expecting to throw a specific exception. You catch that exception, and that enables you to assert not only that the exception was thrown, but also you can assert the message inside the exception. So these are the main advantages of this idiom. It enables you to assert on the message. So another advantage of this method is that I can be very specific on the method that I'm expecting an exception to be thrown. So unlike the previous case where any method in the test would throw an exception and I would not know which, here I can be very precise and say I'm saying only if this method throws an exception the test will pass. For example, if I'm calling this other method that throws an exception, output it outside of the try-catch block. And if this method throws an exception, then the test will fail, and I will know immediately why. For example, let's run this to demonstrate. So notice that the test failed because there was an index out of bounds exception thrown here outside of my try-catch block. So this idiom enables me to be very precise, and also to now if I run this method, it will pass, and I can also assert that not only the exception is thrown, but it was thrown with a specific message. So the third and last way of testing exceptions in JUnit is to use the expected exception rule idiom. So you basically declare a rule. These rules must be public, by the way. By convention they are named thrown, but you can name it whatever you want. It's just a convention. And what you do is, let's add our test method here. And what you do is, this is a very declarative way of testing exceptions. So you basically set a bunch of expectations. So set expectation 1, set expectation 2, and so on. And then you do the actual test. So basically what you're doing here, you're setting what you are expecting that's going to happen when you do the actual test. And if all of the expectations that you set here happen, then the test passes. If at least one of them fails, then the test fails. And this way of declarative setting expectations before you do the actual test is very common in mocking frameworks like Mockito, which we will cover in the next course. So let me set a bunch of expectations here to illustrate. So what we've been testing is that an array index out of bounds exception is thrown. So that's my first expectation. And also that it is thrown with a specific message, that it contains an array index out of bounds exception. And now I'm going to do my actual test, and throws an array index out of bounds exception. So basically I'm expecting that when I invoke this test, that it will throw this exception type, and that the message of the exception will contain this string. Okay, so let's run and see what happens. So notice that it passed. Let's say that I'm expecting that the array index out of bounds exception is thrown, but I invoke a method that throws an NPE, then the test should fail. And it fails saying that I'm expecting an array index out of bounds exception, but I actually got an NPE. Okay, so this concludes the 3 options that JUnit supports for exception testing. So I hope you found this video useful. Thanks for watching. Okay, so in this video lesson we're going to cover parameterized tests, which is a core JUnit feature which enables you to essentially define the input data to your test, and then the framework will inject those parameters and create basically combinatorial permutations of the tests using those input data. And it's a very compact way of doing tests that require a lot of different combinations of input data. So I've got here a very simple factorial class. Let's just implement it, very simple. Let me just create a public static int method compute. It takes n, and then let's just do if n is less than 2, then return 1. Otherwise, let's just return n times compute n minus 1. So that's a very basic implementation of the factorial. Let's create a test for it. Okay, so now we have a test for the factorial, and let's write a basic test. So let me add my test method, test factorial. Let's say I'm interested in testing the first 5 inputs to the factorial function. So I would write assert that. So actually is factorial compute 0. Then I'll use core matchers is core matchers equal to 1. So that'll be the first input. Let's just convert these to static imports to make this thing simple. And then obviously I'll write a bunch of them. I'll test factorial of 1, I'll test factorial of 2, factorial of 3, factorial of 4, and factorial of 5. Now if I were to run this, then it passes. Okay, so this is how you would do it. Now let me show you how you would do the same equivalent test but using parameterized tests. So the first thing you do is you have to tag your test with the parameterized class. So this effectively uses a different runner, and then you create a private int field which is the input to the test, and as well as the output. You can call it output or expected. Okay, and let's add a constructor. So now we have the input, the expected value for the function, and a way to inject these values. Okay, we tag the function that injects the values with the parameters, and we create a public static collection of basically object arrays. Okay, let's call it data because that's what we are injecting. And here let's create on the fly the pair of inputs and expected function outputs. So let's create a new object, and then let's do this, let's close. Okay, so now we're going to be creating the pair of values. So factorial of 0 is 1, factorial of 1 is 1, factorial of 2 is 2, factorial of 3 is 6, factorial of 4 is 24, and factorial of 5 is 120. So effectively what we've done here is we have specified the input parameters to the tests, and this is nothing but these inputs here are going to be passed the constructor, and for each pair here we're going to be creating an instance of this test. And then what we're going to be doing here is on the test method, test factorial function using parameterized tests. Here we're just basically going to be using these values to write our test. So we're going to assert that given the factorial compute method with input, that is equal to the expected value. Okay, and if I run this, then it passes, but also notices that what happened here. So for each of the input and expected pairs, I got one test. So this is a nice way for you to specify tests without having to write all of the possible invocations with inputs and outputs. In case of failures, this might not be very descriptive, because we just see a bunch of index, we don't really know what's going on. So the parameters annotation here takes this name, and you can basically here define the the name for your test. So we can still keep the index as it was defined before, but now I can write the name of the function factorial, and I will pass the input, which is the first parameter. Okay, and that produces the output, which is parameter 1. So if I now run this test, notice that now I have the appropriate name of the function with the input parameter and the output. So now in case something fails, I can immediately see, okay, what is the test that failed given what input or expected output was. So another way that you can do dependency injection of the inputs and expected outputs for parameterized tests is by using the parameter, and this parameter annotation takes the the index of the value here that you want to inject. By default it starts with 0, so you don't have to, the default value is 0, so you don't have to parameterize it here. But just to be very explicit, let me parameterize it. Another requirement of the parameter annotation is that the fields have to be public. This is so that through reflection JUnit can inject the values. And if you do that, then you basically are replacing constructor injection with field injection. So this is exactly the same thing as this. This does not require a constructor. You can just inject your annotate your fields with this. So now if I run this, then it should work just like before. So to conclude, this is parameterized tests using the parameterized runner is a very nice way for you to run tests or specify tests that have a lot of permutations of the input data for a test. So this concludes the introduction to parameterized tests in JUnit. Thanks for watching. In this lesson we are going to cover rules in JUnit 4. So what are rules? Rules are a mechanism that essentially allows you to extend the behavior of a JUnit test by leveraging this rules mechanism. Essentially rules, everything that rules provide, you could do it manually, either via an util class or maybe by putting behavior on a base class that each of your test classes would extend. But as you will see, it's just a very convenient, foolproof, bug-free way of encapsulating behavior that you compose your test classes with, as opposed to be extending base classes. So JUnit 4 as of now comes with these provided rules. So basic rules are split into provided rules, which is rules that you can just use as is, and then custom rules. Custom rules is nothing but the JUnit 4 mechanism that allows you to extend the behavior or implement your own rules or extend the behavior of an existing external resource rule, for instance. So we're going to cover each of these provided rules here. So the first rule, which is the expected exception rule, I have already covered in the exception lesson. Please refer to that lesson for details on the expected exception rule. So let's cover the temporary folder rule. So recall that from the exception lesson, when we use the expected exception rule, that rules are defined by using the rule annotation, and then you basically do public final temporary, and then you put the name of the rule. Okay, new temporary folder rule. Okay, so this is essentially how you declare a rule. You tag it with the rule annotation, and you define the rule as a field of your class. So now what does this rule do? So as you can see from the name, this rule extends the behavior of your test by providing a mechanism to create temporary files or folders that are, as the name implies, after you're done with your test, they are automatically deleted and cleaned up. So every time you have a test that needs to create some folders or some files, as you can imagine, it's a pain for you to manually have to create those files and then release or delete those files. So temporary folder rule enables you to do all of that automatically without you having to do all of that boilerplate code. So if you look at the interface, you basically have a way to have a few factory methods here. So you can basically create a file, a temporary file, or create a temporary folder. If you create a temporary file, you have two options. One is the option without an argument creates a randomly named file in the JUnit temporary folder, And this option that takes an argument obviously creates a file with that name. The folder factories, there are three folder factories here. The new folder just creates a randomly named folder. This one creates a folder with that name, and this allows you to, via these var arguments, to create deeply nested folders. So for the sake of this example, let's use the new file, and let's just give some file name, and let's assign this to a local variable here. And I suppose I could also create a new folder with the name foo. So let me add a breakpoint here and debug this test for you to see where each of the files are being created. So notice that the file has been data.txt is being created on this randomly generated JUnit folder, as well as the foo folder file. So one thing before moving on is that as of version 4.12 of JUnit, one limitation of the temporary folder rule is that if for some reason you cannot delete the temporary folders of files, you are not notified about it. You don't get any error. So starting at version 4.13, I think, they added the ability to do a strict verification of the ability to delete these temporary resources, files or folders, and if that fails, then you get an assertion failure. So, and that's basically what you would do. So the usage is exactly the same, the type is the same. You just use the builder pattern to create the temporary folder rule. It's red here because I don't have the version I'm using is 4.12. So the next rule is the that we're going to cover. So we cover the temporary folder rule. Let's talk about the test name rule. Okay, so let's add our test method. So as you can imagine, the test name rule is a rule that enables you to get access inside the test to the name of the method, and run a very simple assertion for you to see how to use this. So test method, assert the test method, then let's use the core matcher is core matcher equal to name get method name, and as usual let's just import this statically and here as well. Okay, and obviously if I were to have another test method here, then if I were to run this, actually let's just run the whole thing, then it passes. Okay, so moving on, the next rule we're going to cover is the timeout rule. So the scenarios are when the test is executing a long operation, perhaps connecting to a database or loading some resource off of a socket connection, or doing some lengthy operation, perhaps some crazy scientific computation, and you want to make sure that the test doesn't exceed a certain upper bound. And if it does, you basically want to fail the test. So just like before, you just do a public final timeout, give it a name, the type, and let's just give a timeout name here. And they have this factor here called, so this actually, you can specify the time in milliseconds or seconds. For the sake of this example, let's just specify in seconds. And let's say that I want the upper bound for all of my tests to be, say, 2 seconds. And now in your test methods, basically, this rule is going to apply to all the tests inside this test class. And every test that exceeds 2 seconds will basically fail with the timeout exception. So for example, let just run a simple test here, and then let me sleep for half a second. So test rules method lasted 4, and let's obviously add this exception, and let's run this. Okay, so this test passed because it basically ran for 501 milliseconds, which is less than 2 seconds. So now let's add another test method. So basically this is a test that will never finish, and let's see what's going to happen here. Okay, so after 2 seconds, the test has failed with the timeout exception because it lasts for more than 2 seconds. So now if I run the entire all the tests inside this test suite, Notice that the test method passed because it lasts less than 2 seconds, whereas this test failed. Okay, so moving on, the next rule that we are going to cover is the error corrector rule. The error corrector rule is used in scenarios where in your test you are doing an operation that creates a problem, generates an error, and you want to continue the execution. So you don't want to stop at the first error. You want to collect all of the errors and then at the end see what passed, what failed, and so on. So to demonstrate this, I've got here a very simple class, component under test, that basically throws an NPE, an array index out of bounds exception, and a method that doesn't. Let me just create the component under test. Okay, so again, I mean, this is just a simple example. You would not instantiate this component under test inside the test method. With that caveat, let's demonstrate the use. So under normal circumstances, if you just call under test throws NPE, then obviously your test will fail. You will know about the error, and that will be that, right? So that's a normal execution of JUnit. But let's say that you don't want that. Let's say that you want to do a bunch of operations in this component of the test, and then at the end be notified about all the errors. Essentially, you don't want to stop the execution at the first error. You want to continue till the end. So what you do is wrap this on a try catch, and here you'd use the collector rule to basically add the error. So we just add the exception, and here you can also check that the value, for example, let's say the message, you could assert the message is core matchers equal to the null pointer exception, and you do the same for the other method under test that throws the array index out of bounds exception. Okay, and obviously you could be doing other operations like under test foo. Okay, so let's run the test and see what happens. So notice a couple of things here. So firstly, the test fails because even though I'm catching the NPE here, because I'm reporting an error on error collector rule, the test will be considered to fail. So this error is going to be considered a test failure. It's going to be reported. It's not that the error collector just swallows the exception, and lets your test pass. No, the test is failing because an NPE is thrown. We enable the test to continue to proceed execution even after the first failure, and we're collecting all of the errors here. So at the end, we report that the test failed, but we have more information because we see all of the failures, not just the first. So if you look at the console here, you will see that the 3 methods were invoked. The first that throws the NPE, the foo that doesn't do anything, and the last one that throws an array index out of bounds exception. And then we have these 2 failures, 2 exceptions here that were thrown. Okay, so let's move on and cover the external resource rule. And this is slightly different rule in that it doesn't really have basic behavior. You have to implement it. So let's assume, for example, that I have here a server which has a connect and disconnect methods. Again, just a very simple example to illustrate an application of the external resource rule. So then I have here my server. Let me just instantiate here for the sake of this example. And here on the before method I would connect, and on the after method I would disconnect. Okay, so now let me implement the test method 1, and let's just do this, and test method 2, and do that. So let's run this method and see what happens. Okay, so I see server connect. So this is why don't we split this thing here? So when the test method 1 is invoked, so notice that the before rule is method is called first, which connects to the server, and then the method, the test method runs, and then the disconnect method, which is the before on the rule, it's invoked, and the same thing, the same pattern of execution for the other method. I mean, obviously this is not exactly what we want, because this is essentially the before and after annotation methods behavior. Okay, what we want is for this to be called only once the server connect, before every test, and then the server disconnect to be called at the end after all tests have executed. Okay, so now let's see how we can improve this so that this rule is ran only once at the beginning and then after at the end to disconnect from the server. So this is where the class rule come into play. So as you see, all of these rules are applied to a test methods. So what we want to do is we want to convert these from a test rule to a what's called a class rule. It's a very simple change. The only thing we need to do is change the annotation from rule to class rule. So the first thing we need to do after this change is to change the resource to static as well as the instance. So now with these three changes, let's run all of the tests here and look at the behavior. So now as you can see, we have the exact behavior that we want. So server dot, which is the before class and the after class behavior. So server dot connect is done, it's invoked in the beginning before each test is invoked, and then each test runs, and then at the end we disconnect from the server, cleaning up the resources. So this is exactly the behavior that we wanted. Now obviously one thing we need to do is we don't want this to be inside the a test class, because the whole point of this rule is to be reused across different tests. So let's extract a class here. Okay, so now that we have extracted our server rule, basically the only thing that I've done is just extract that anonymous inner class into a top level class, which still extends the same external resource rule. And here, in your test method, the way you would use it is we would use a class rule, public static final, and we'd call server rule, which is the resource, and instantiate it. Okay, and then here I can get my server and invoke some method foo here and here. So now let's run this and see if we still have the same behavior. So as you can see, we still have the same behaviors. Okay, so before wrapping up this quick overview or introduction to JUnit 4 rules, let me just cover the very quickly the rule chain. And you basically compose or chain these rules. Say you have an outer rule here, and then you put around as many as you want, and then and then that's that. So this is a way for you to chain or to essentially specify an order of the rules to be applied for each test method. With regards to custom rules, I've already shown you how to define a custom rule, one of the ways. So one way is to extend an external resource and implement the before after methods. Another thing that you can do is to basically implement a test rule interface. So this wraps up the quick overview of JUnit 4 rules. I hope you found this introduction to JUnit 4 rules useful. Thanks for watching. In this video we're going to cover JUnit test suites as well as JUnit 4 categories. So I've got here 4 test classes. So I've got here performance tests, I've got here a suite of integration tests, as well as 2 feature tests. So again, this is just an example to show the the power of JUnit 4 in terms of test suites, and this is obviously a contrived example, but this will do for this demonstration. So with this categorization or suites of tests in IntelliJ, you can basically come to the runners or the containing package and run all the tests here. And notice that all of the tests ran, and you can see that the tests, just by running the package, all of the tests were executed. And I've got each of the tests print their test name. So just by clicking here, I know that these tests ran. But this is a convenience that IntelliJ provides in terms of a graphical runner. But notice that I don't have control on the orders that these test suites are running. Moreover, if I am running these with a tool like Gradle or as part of continuous integration, say TeamCity, then I would need to have a way to group these tests, as well as to have the ability to specify an order. And this is where the test suites come. So now let's see how I can group these tests into a test suite and specify an order. So for this, JUnit provides what's called a test suite. The way you define a test suite is as follows. So let's create a class called my test suite. You basically tag it with a there is a special runner called suite. So this is how I'm defining my my test suite, and I need to define suite classes. So in here we are going to specify all of the basically the composition of this suite, and this is nothing but the names of the test classes that are part of my suite. So I have the performance, and I have the integration tests, I have the feature 1 test, as well as the feature 2 tests. So this is how you define a test suite in JUnit 4. So you specify a public class and you tag it with use this special suite runner, and you use this tag suite classes to specify tests that comprise this test suite. Now let's run this and see what we get. So notice that I have the test suite here running, and the results, everything ran correctly. And notice one thing now, I have control on the order of this test. So for example, if I want the performance test to run last, or an integration test, so I want to change the order here. I want my feature tests to run first, followed by the integration test and performance test. And if I were to run this, notice that now the tests ran in the order that I specified in my test suite. Now another thing that I can do is have a suite of suites. So for example, let me create another suite class, which I'm going to call say super suite, or my super suite. So just like before, run with suite, and also use my suite classes. And in here I should be able to specify my test suite class. And perhaps I could have defined here a so this is still a placeholder, and if I had another test, for example, let's create another one, regression tests, and in here I would have a regression test, and I could add this regression test to my super test suite. This would run last, for instance. So now if I run my super suite, then notice that all of the tests inside my test suite ran in the order specified there, followed by the regression test. So you can compose suites with suites. Okay, so moving on. Let's say now that we have this nice test suite and everything is good, but for whatever reason we notice that feature 1 test, for example, is a flaky test, meaning it passes or it fails randomly for the past n runs. So we want to investigate this test, but for now we just want to mark it as, or put in a category of flaky test, and we would like to exclude that from the test suite. So this is where, or this is one scenario where the categories in JUnit 4 comes into handy. So categories is essentially another type of runner in JUnit 4, and it enables you to categorize tests and then filter, include them or exclude them in your test suite. So the first thing we need to do is we need to specify a marker classes, or interfaces I should say. So let's define here flaky tests interface. So now let's go back to our test, and the way you tag a test as a flaky test using categories is essentially by adding the category tag. and you mark it with the flaky test. Okay. Now you can tag a test method or an entire class, but for now let's work with a tagging just an individual method. So let's say that we found that this feature 1 test 1 here is a flaky test. You know, feature 3 here, this test is also a flaky test. Categories, like I said, is a special runner. So let's say here that let me create a flaky test. And to use the categories, you basically use the categories runner here. And because we are defining so let's include the feature 1 tests as well as the feature 2 tests. Okay. So we have here the 2 classes that have the flaky tests, and now we want to include the category. So now again, this is just a placeholder, and if I run this, I should expect to see only my 2 flaky tests, okay, which are these 2 ones that I tagged, feature 1 test that I tagged with the flaky test, as well as this guy here. So this is a nice way for you to categorize tests and run just a specific type of tests. Now this is a flaky test suite. I could have obviously defined the opposite, which is a, let's just say, all but, you know, flaky tests suite. So let's just get this stuff to here, and again, this is just a placeholder. And essentially what I want to do here is I want to exclude the flaky tests category, and I want to add my test suite. So what I'm defining here is I'm defining my entire test suite, okay, which, if you recall, has all of the tests. I mean, I could even put my super test suite here. So recall that my super test suite includes my test suite as well as the regression tests. And what this category is doing, as the name implies, is running all the tests but the flaky ones. Okay, so it's including my test suite and the regression test, and for my test suite, it's excluding the flaky test 1 here. Feature 1 test 1 is a flaky test, it's not running. And from feature 2 tests, it's running feature 1 and feature 2. Recall that feature 3 has been tagged as a flaky test here. And for the integration test, is run integration test 1, 2, and 3, which is all of them, and performance test is running performance test 1, 2, and 3. And if you see here, you will see that all of the tests in that suite. So to demonstrate the power of categories, let me show you another example. So a test method or a class can belong to more than one category. So for now, I've just showed you a test method or a class that belongs to a single category. So now I'm going to demonstrate you how you can make a test method or a test class belong to more than one category. Let me create here a feature tests category, just similar to the, so obviously I want an interface, just similar to the flaky tests category that we created. So remember, these are just marker interfaces here. Let's tag both this class as well as this with a this category. Okay, so now we have both feature test classes belonging to the feature test category. And now let me define a suite for it. Okay, let's just move this thing here. Let's expand. Okay, so let me copy all of that stuff here. I want to include all of my feature tests, but I want to exclude all of my flaky tests. Okay, what I've defined is a suite of tests that basically includes all of the feature tests but excludes the flaky ones. So if I run this, then all of the tests here should be excluded, because remember, all of these tests in this class belong to the flaky tests and the feature test category. So if I exclude the flaky test, then the entire test here should be excluded. because this is an and. It's a flaky test and a feature test. So if you exclude either, then the entire test should be excluded. This test belongs to the feature test category. But notice that this test here, the test 3, it's a flaky test. So these two tests should be included because they are part of the feature test, which is being included here. But the flaky test, which is this test 3, should be excluded. So when I run these all feature tests without flaky tests, the only two tests that should run is feature 2 test 1 and feature 2 test 2. So notice that that is the case. Okay, so I hope you found this lesson useful, and I hope I have conveyed to you the power of both JUnit 4 test suites as well as categories, which is a mechanism to filter the tests. Thanks for watching.
Hi, this is Nilton from craftofprogramming.com, and in this video I'm going to show you why you should consider upgrading to JUnit 5. JUnit 5 comes with lots of new features that are not available in JUnit 4, but there are API changes, so that means that you will have to modify your tests to run against the new API. So what I'm going to show you here is the reasons why you should consider upgrading, and given that there will be test code changes. Okay, so basically, as you can see here, there are we're going to cover the awesome new features that JUnit 5 provides, which are not available in JUnit 4. JUnit 5 supports Java 8 lambdas, which JUnit 4 doesn't. And also another point here is that the use cases of JUnit 4 have evolved over time, because JUnit 4 has been around for a long time, for many years. And people are using JUnit 4, for example, for integration tests, and this is something that there is no really support in JUnit 4, but JUnit 5, as you will see, have some support for that. Also, there are some changes or improvements in the modularity, particularly in the way JUnit 5 handles the dependencies. There is a new extensibility model, which effectively replaces the rules and the runners JUnit 4 extension model, which we're going to cover, and as well as a cleaner and simple architecture. Perhaps if you're just writing tests, you're not really concerned about the architecture, but for people that build tools or IDEs, this is really a concern and something that they will, they pay attention to and they value. We're going to cover also the forwards and backwards compatibility. So JUnit 5 is actually forwards and backwards compatible with JUnit 4, which is a good thing. And this is obviously done by design so that people can transition slowly from JUnit 4 to JUnit 5. Okay, so the new features that JUnit 5 supports are pretty much these are the main ones. So there is a new tag annotation. You can basically define meta annotations, which is your own sort of custom annotations, which are built on top of the built-in annotations. There are nested annotations, repeated tests, parameterized tests, test factory, and display name. We're going to cover one of these, each of these in turn. So tagging tests. So in JUnit 4, you basically would use categories to do something equivalent here, and this tag basically enables you to just pass a string, and that's how you would tag your tests. For example, here my test, I am basically using the tag slow and tag integration to tag this my test. That's how I would, basically tag these. And one other way that you could do the same thing is to define a meta annotation, which is this case here on slow integration test, where, as you can see, we're defining a tag integration and feature to define a slow integration test meta annotation that then you can use in your test. So both ways are equivalent. One uses just the built-in tags, another one uses a custom or meta annotation tag, but both are equivalent. Obviously, if you define this slow integration test custom or meta notation, then it's more expressive. So this is a really nice way for you to tag your tests, and then you can use these to basically do, includes and excludes, just like the way you did for categories. So this is a brand new feature, JUnit 5, and it's less boilerplate code, less code to write, and for similar feature that you have in JUnit 4 for categories. So another new feature of JUnit 5 is nested tests. So now you can actually put effectively inner classes inside of classes for tests, and you can group your tests like that. This might be useful in for example, the canonical example that JUnit 5 shows is, for example, when you're testing a stack, which is almost a deeply nested feature, data structure. And you can basically nest in with arbitrary depth or nesting level. You can do a nesting like that. So that's a nice way to group your tests when you are actually testing a data structure or something that has this nesting or inner classes structure, and your test is basically mimicking the structure of the code that you're testing. So that's the nested tag feature. Another one is repeated test. So the @repeated, and then you pass a number, an integer, which basically represents the number of times that you're going to run this test. And this is useful, for example, if you are testing some integration test, which maybe it's flaky, and you want to run it, n times, in this case 42, to perhaps trigger some kind of problem that only happens, after a certain times of runs. I mean, this is just one use case. There are many other use cases for the repeated test, but this is, one very useful case or scenario for the repeated annotation. So another one is the parameterized tests. So as you know, in JUnit 4, you could write parameterized tests, but the parameters tag was applied at the class level. And the big difference from JUnit 4 and JUnit 5 in terms of the parameterized test is that now you can have parameterized tests tags at the test method level. And the other difference is that the parameterized tests in JUnit 4 were a special type of runner. And that meant that you couldn't, for example, use parameterized tests with, say, categories, because they were basically, two different runners, and you could only have one runner per class. So now, the fact that now you can define parameterized tests at the test method level, you get basically two things. Firstly, you can have each test in a class can have its own parameters, sources, as I will show you, and also you can then group now in the same test. You can use a parameterized test, say, with categories, or the similar mechanism of categories, which is the tag that we covered in the previous slide. So in this example here, for the foo test method, we have a CSV source, and basically what that does is, you can see, we're basically passing, in this case, a pair of a string and an int to this method, and we're going to have basically two invocations of this method with those two pairs of parameters. And what you need to understand here is that the parameter types obviously have to match. So the other way you can define a parameterized test is using a method source, which is basically, as you can see, it provides a factory method to inject the parameters onto the test method. And the third one is basically sourcing it from a file. So the other feature is that JUnit 5 supports is dynamic tests. And as you can see, and this is using the test factory tag. And this is a really cool feature, because this basically is creating dynamically on the fly your actual test methods. Basically, there are different methods that you can, or ways to generate. In this case, I'm creating a stream of dynamic tests. You can get a collection of dynamic tests. This is just an example. But the fundamental feature here is that the test body is actually being generated dynamically. And in this particular example that I have here, for each of the values of this string, which is foo and bar, these two strings, I am mapping them onto a dynamic test whose first, here as you can see, whose first argument is the name of the test, and the second argument is effectively the body of the test method. So, and what I'm doing here, I'm just asserting that the length of this test name is equal to 3. So this is going to generate two dynamic test methods, one named foo and the other one named bar, and where the body of each of these two test methods is just basically containing this lambda, which asserts that this test name is equal to 3. So as you can see here, this is slightly similar to parameterized tests in that we have a bunch of inputs that we are passing to a test. Here you are actually creating the test body on the fly dynamically. So this is a really useful feature that I think it's something that makes JUnit 5 a very powerful testing framework. So the other one, which is I think it's also a big one, is the way exceptions are handled. So if you recall in JUnit 4, there were 3 ways to actually test exceptions. One is using the try-catch idiom, the other one is using an expected exception rule, or the other one is just tagging the test with an exception that you would expect to be thrown in your test method. So these 3 ways of doing exception testing were basically unified into a single way, and that's how JUnit 5 now tests exceptions. So you basically have these assert, throws, a call here method. The first argument is the name of the exception that you are expecting to be thrown, and the second argument to a third throw is basically effectively the test body. So this is what you are going to test. This is a piece of code that you are expecting to throw this exception. And then a third throw gives you back the exception so that you can then assert the message that the exception wraps. So this basically does everything that we need, right? We can specify explicitly the exception that we expect. We specify the code that is supposed to throw this exception that we're expecting, and then assert throws gives us back the exception so that we can assert the message. So this is a unified way to test exceptions, and it's clean and it's neat and it supports lambdas, and I think, in my opinion, it's a nice way to have a uniform, consistent way to test exceptions, as opposed to JUnit 4, where we had those 3 competing ways to test exceptions. Another one, I mean, this is a slightly small one. You can basically now tag or specify a custom test name, and when this test runs, instead of saying complex math, you will actually see 1 + 1 = 2 as the name of the test in the output. And this might be useful for cases where you need that really expressiveness on the test name, which matches the test body. Until now, I've shown you all the new features of JUnit 5 and the reasons why you should consider upgrading. I mean, learning JUnit 5 and upgrading. And that's the point of this tutorial, of this course tutorial of JUnit 5. But one thing that I want to mention here at the end is that rules are not supported in JUnit 5 any longer. So I have another, in the next video I will go into the details about rules and runners when I cover the JUnit 5 architecture. But what I want to show here, or I want to say here, is that rules are not supported anymore. So what they have provided is a way to basically support JUnit 4 rules, but as you can see, it's a limited support. Basically, just support external resource, where temporary folder an example of, verifier, and expected exception. So it's a limited support of the existing JUnit 4 rules. And the way you do it is you use this @enable rule migration support tag at your tests. As you will see in the next video, the reason why rules have been pretty much discontinued in JUnit 5 is because they effectively compete with the runners mechanism, and the JUnit 5 designers made the decision to have a single unified extension model as opposed to have runners and rules. So they basically collapse both of these concepts into a single extension model using the extended with annotation. Okay, so I think this ends all of the features, new features of JUnit 5, and why you should consider upgrading. In the next video, we will talk about the details of the extensibility model as well as JUnit 5 architecture. Thanks for watching. Hi, this is Nilton from craftofprogramming.com, and in this video I'm going to cover the details of the JUnit 5 architecture as well as the new extension model, which is key or core of a feature of JUnit 5. So we're going to cover the improved changes in terms of the modularity in JUnit 5. Its architecture, which is much cleaner and simpler. And we're going to cover the extensibility model of JUnit 5, as well as the compatibility that aids, in the migration from JUnit 4 to JUnit 5. So this is a slide which is due to Mark Phillip from JUnit 5 team, and this is basically to highlight the problem of JUnit 4. So the issue is that JUnit 4 had, as you can see, a single monolithic jar, which you as a test implementer would depend upon, or you as an IDE builder would depend upon, or if you're writing some build tools like Gradle or Maven, you would depend on that, or if you have a third-party testing framework like Spring, you would depend on that too, or if you're writing some JUnit 4 extension, you would depend on that. So this dependency on a single monolithic jar was an issue for the library to evolve. So in this new architecture, this is again a credit to Mark Phillip for the diagram here. You can see that there are basically a much cleaner API here. So you as a test implementer, you would be basically using the Jupyter API, which is here in green. So the only thing that you really need to depend on, and you should care, is to depend on the Jupyter API jar. So that's the key dependency that your tests are going to depend on. And the vintage in yellow here is basically provided for backwards compatibility, and this is so that existing JUnit 4 tests can run in the new platform. So, and also they created this platform here in red, which basically enables the people that implement build tools like Maven and Gradle, as well as the IDEs like IntelliJ and Eclipse. They would basically need to have the access to JUnit 5. They would depend on the platform. people that write tests would depend on the Jupyter API, and old JUnit 4 tests would depend on the vintage API. And there is also third-party here dependency. So notice that the dependencies here from for example, if you're writing a JUnit 5 test and you depend on the Jupyter API, notice that the Jupyter API, you depend on the Jupyter API, and you don't care about what's under. Under the hood, you see that there is a Jupyter engine which effectively implements the API. The Jupyter API is a jar that mainly contains just interfaces. So the implementation of those interfaces are on the Jupyter engine, which then talks to the platform engine to actually run your tests. And the JUnit platform launcher here in the platform, as you can see, basically is the way to launch the tests, and that's how an IDE like IntelliJ or Eclipse will use to launch your tests. So they give the tests to the launcher, which then tells the engine to run them. And this surefire provider is for Maven to be able to run a JUnit 5 tests in the platform or in the engine. And the Gradle plugin, again, is to run Gradle tests. So that's a dependency for these two Maven and Gradle build tools. The other one here that you see, JUnit Platform Runner, is basic for forwards compatibility, and this is so that old IDEs that don't yet support JUnit 5, you can basically run JUnit 5 tests. So that's a way for forwards compatibility. But the main thing that you should be concerned here is that there is now a clean, neat separation of concerns, a clean, neat architecture where people that are writing tests just depend on the Jupyter API jar. People that have old JUnit 4 tests just depend on the vintage engine via the JUnit 4.12 jar. Platform, implementers like IDEs and build tools depend on the platform, and there is a third-party dependency here for people that are writing, third-party, frameworks that integrate with JUnit. They would depend on the platform as well. So now let's cover the extension model, which is another big change in the JUnit under the hood. So, and this addresses the drawbacks of JUnit 4 in terms of how the extension model was handled. So, as you can see here, there were two ways that you could extend a JUnit test. One was via runner, another one via rule. And the reason why they were competing is because the runners basically, as you can see here, there were basically categorized in terms of graphical runners, which were supported by any IDE like IntelliJ or Eclipse, and this is what enabled you to create a JUnit test, and then just run it, or go to a package or an entire project and just run all of those tests. So when you do that, the JUnit, the IDE was creating a graphical runner to basically run your tests. So then there was this other way that you could use the run with tag. And the run with tag basically was a way for you to use either a built-in runner or a custom runner. So we had the default runner, which is the block JUnit 4 class runner. We had categories, which was a way to categorize tests, and you could basically include and exclude, a test suite like that. We had parameterized tests, suite of tests, and also experimental runners with the enclosed, and obviously third-party runners. And this was a way that third-party tools, like for example Spring, you could integrate with the JUnit via this runner, mechanism. So it was flexible in a way, and it was powerful because you could do all of those things, but one big limitation was that you basically could only have one runner per class. So for example, let's say that you want to use categories to filter certain tests, but you wanted to use parameterized tests as well. In JUnit 4 you couldn't do that because you could only have one runner per class, and both categories and parameterized tests are runners. So that was a big limitation of the runners. And then I think JUnit 4.7 introduced rules as a way to address the shortcomings of the runners mechanism. So rules are basically a really nice way to extend or to customize and to extend the behavior of a test. And when JUnit, and you could do that at the test method level or at the test class level using the @rule annotation or the @class rule annotation. And JUnit 4.7 introduced the temporary folder rule, error code collector rule, test name, timeout, expected exception, class rule, external resource rule, and rule chain. And these are covered in this course. I have a lesson on rules. Please refer to that. And one nice thing about rules is that in a single test you could combine them. More than one rule, unlike the runner. The issue or the shortcoming with rules, as you can see, was that you could either apply a rule at a single rule at a method or at a class. So this was a shortcoming of rules. And because of this issue so you had these two ways to extend JUnit via runners or rules. And because of the limitations that they had, JUnit 5 introduced a completely new extension model using the extended with or extend with tag. So this is supposed to be the way that you extend the behavior of tests, and this should supersede or replace rules and runners in JUnit 5. So as you can see, unlike rules, you can apply the extend with at a class level and at a method level. And unlike runners, they can be combined, which seems something that rules provided. And you could also define meta annotations or your own annotations to have highly expressive tests. So again, the key takeaway here is that JUnit 5 does not support runners anymore. There is limited support for rules. And you should really be using the extend with mechanism as the single extension model in JUnit 5. So the extensibility model in JUnit 5 is basically comprised of these three categories. You have the conditional test execution, general purpose extension points, and extension points which are tied to the life cycle. So these are basically just interfaces that you would have to implement to customize, the callback behavior. So conditional test execution category is basically the ones that control whether or not a test run, and container is at basically the entire class, and test is a condition on whether or not you want a specific test to execute. The general purpose test instance post processor is the behavior or callback that is called after a specific instance of a class runs. Test execution exception handler is basically a callback or handler for exceptions that are thrown by any test. And parameter resolve, as the name implies, is a mechanism for you to customize the parameters that you can inject onto a JUnit 5 test method. And the test lifecycle callbacks, as you can see, they are basically tied to the main lifecycle of JUnit 5, which we're going to cover. So lastly, compatibility. This is a way for you to migrate easily existing JUnit 4 tests onto the JUnit 5 framework, or engine, I should say. And it's basically through the JUnit Vintage engine. So you don't have to actually or modify your tests against the Jupyter API, which is the new API in JUnit 5. So that's why this is provided. So forwards compatibility was a way that you could basically run your existing JUnit tests on the JUnit 5 platform engine in IDEs that didn't yet support JUnit 5. So I believe that today, as March 2019, pretty much, the modern or popular IDEs like IntelliJ and Eclipse support JUnit 5. So now you have a better understanding of the dependencies in JUnit 5 and the new architecture, as well as the new extension model in JUnit 5. Thanks for watching.
And in this video, I'm going to show you how to set up a JUnit 5 Gradle project using IntelliJ IDEA 2019.1. So the first thing we're going to do is we're going to create a new project. We're going to select Gradle. Let's pick the JDK 1.8. Let's enter the group ID, craftofprogramming.com. The artifact ID will be JUnit 5 Gradle example. And let's just leave these defaults and leave this default location and default Gradle project name. Good. So now we have our project created, and if we open the Gradle window, we see that we have the tasks here, and we can assemble this project, and everything is good. So this Gradle project is using Gradle wrapper, which is pulling or using Gradle 4.10 here. This works because from version of Gradle 4.6 onwards, we have native support of JUnit 5. The only thing we need to do is in the Gradle project, we need to add a dependency with JUnit 5. So we just add an element here, and the only thing we need to do is we need to say use JUnit, if I know how to type, JUnit platform. Good. So that's the only thing we need, and this is obviously using JUnit 4.12, so let's comment this for now and add the dependencies with JUnit 5. So recall that the dependency with JUnit 5 is through the Jupyter API as well as the Jupyter engine. So for JUnit 5 we have to add two dependencies here. So the first one is org.junit.jupyter. That's the group, and the artifact name is JUnit-jupyter-API. And let's pick the latest version, which is 5.4.1. So that's for the API, which is a compile time dependency. And let's add a runtime dependency for the engine, which is we just need to change the API to engine. Okay, so that's it. You just need this compile time dependency with the Jupyter API, and you need this runtime dependency with the engine. And you need to add these so that you have native support of JUnit 5. So now to test as this works, let's create a test, a JUnit 5 test class. And let's just use JUnit 5 sample test. Okay, so let's add a test method here. And notice that when I added this test method, I already got the correct import. The test method now comes from the Jupyter API. And another thing that I'm doing is notice that IntelliJ is already suggesting here something, which is that I don't need the public, so I can make it package private, both the method and the entire class. This is a new feature of the JUnit 5. So let me just add a few things here. Let me add a basic assert equals I don't know, that 2 equals 1 plus 1. Let's complete this and let's import static. Good. So notice that assert equals is also coming now from the assertions package, which is part of the Jupyter API. Let me add another test method. Again, remove the public from the signature, and obviously let's just call it flaky test. And because it's flaky, let me add the disabled. Let me call flaky test, and just print something here. Good. So now we have the as simple as it gets, a JUnit 5 test, where we have a test method that just does a basic assertion, and we have another disabled test. So let's go back to our Gradle window and let's run this test task and see if it works. So notice that 2 tests pass. Okay, the one was ignored, which is the flaky test, and our test method ran. So we have here the output. Okay, so this is how you would use the latest and greatest Jupyter or JUnit 5 using Gradle. So you just need basically these to add these dependencies with the Jupyter API and the engine and the native support here. Now another thing I'd like to show you is how you would configure a Gradle project for backwards compatibility. So the only thing we need to do here is we need to swap out the Jupyter API with the JUnit. Okay, so this is basically pulling the JUnit 4.12, but what we need to change here is to use the vintage engine and vintage engine. Okay, so that's it. So that's pretty much what we need to do. So now let's go back to our test, and obviously, we're gonna have to make it a JUnit 4 test. So the first thing we need to do is let's just rename this guy to JUnit 4. Okay, let's just do this refactoring, and let's import the test from the JUnit 4 instead. Okay, so we have a basic, our plain vanilla JUnit 4 test, and let's go to our Gradle window and run our test. Good, so as you can see, 2 tests ran, 1 is ignored, and our test method passed. So this is how you would set up Gradle to run a JUnit 4 tests in the new JUnit 5 engine. So I hope you found this video useful. Thanks for watching. This is Nilton from craftoffprogramming.com, and in this video I'm going to show you how to set up a Maven project that works with JUnit 5 using IntelliJ IDEA 2019.1. So the first thing we're going to do is let's create a brand new Maven project. So in the new project window, let's select Maven and let's choose the JDK 1.8. Let's click next. The group ID, as usual, craftoffprogramming.com. Artifact ID is going to be JUnit 5 Maven example, and let's just change this name to match the artifact ID. Let's leave the directory and let's click finish. And good, so we have a bare bones Maven project. Let's go to the Maven window here. Good. And lifecycle, let's just do a very simple compile. Make sure that everything is good. Good. So we have a successful build, everything is good. So now what we need to do is we need to add the dependencies with the Jupyter API and the Jupyter engine to have support for a JUnit 5 for our Maven project. So let's do that. Okay, so the first thing I did was I've added a dependency here with the Maven Surefire plugin. So this is version 2.22.1 is required to work with JUnit 5. Okay, so that's the first plugin that we need. So incidentally, you could have used the Maven failsafe plugin, but you know, it's one or the other, so let's just use the Surefire plugin here. And also I've added the dependencies with the Jupyter API using version 5.41, as well as the Jupyter engine, which is using the same version. So notice that again the scope for the Jupyter API is test, whereas the scope for the Jupyter engine is runtime. Okay, so again, let's go to our Maven window and just do a compile, make sure that everything still works fine. Good, still have a build success. Okay, so now that we have the Maven project set up, let's create our test class. Let's call it JUnit 5 Maven test, and make sure this thing that test class name ends with test or test case, because if not, the Maven Surefire plugin just ignores it. Okay, so let's add a test method here. And notice that as soon as I add the test annotation, the correct test import is being added from the Jupyter API. So let's add here some system out, and let's add a basic assert equals something very simple, 1 + 1, something simple like that, and let's add import statement. And again, notice that the assert equals is being sourced from the assertions package in the Jupyter API. Also, IntelliJ is telling me that I can make this, so I can also make the class package private. And let me add another test method. Obviously, let's change the name to flaky test. Let's add some system out here, and just to make sure that this test is not run, again, let's make it package private, and let's disable this. Flaky test. Okay, so what we have here, we have a plain simple JUnit 5 test with a very simple assertion here. One of them is using the new disable. This is equivalent to JUnit 4 ignore, and this is basically just to test the Maven project that we set up. So let's run test, the test lifecycle phase here, and see. Okay, so notice that Maven has correctly ran our tests, and it detected no failures and no errors, and one test was skipped. Okay, and you can see that the test method here, printout, has been printed here. Okay, so this is how you can see how simple it is to set up a Maven JUnit 5 project. So now what I'm going to show you here is how to configure JUnit 5 to run JUnit 4 tests using Maven. I have here the configuration and the previous configuration. So as you can see, the only difference really is I've just replaced the Jupyter API with the JUnit 4.12 dependency here, and the engine. As you can see, I'm using the vintage engine as opposed to the Jupyter engine. Let's go to my tests here, and let's convert it back to a JUnit 4 test. So notice that now Maven is already complaining, it doesn't know about these packages, and so on and so forth. So let's clean this up and re-import this from a JUnit 4. And let's clean this up as well. Okay, assert equals, let's import that from the JUnit 4 package. And this obviously in JUnit 4 it's ignore. And let's make the class and the methods public again, as per the JUnit 4 requirement. Okay, now let's go to Maven and let's run the tests. So as you can see, same thing, our test ran and print this to the output, and another test skipped. So that's basically how you would configure JUnit 5 to run JUnit 4 tests, or how you would configure JUnit 5 to run the latest and greatest JUnit 5 tests using the Jupyter API. I hope you found this video useful. Thanks for watching. Hi, in this video we are going to cover the tag in JUnit 5, and tag concept in JUnit 5 is pretty much the same concept as categories in JUnit 4, which we covered on a previous lesson. So what I have here is the same JUnit 4 category example that we used in the previous lesson, and what I'm going to show you here is how to convert these JUnit 4 test suites using categories to the JUnit 5 equivalent mechanism using the tag annotation. So just very quickly here to review, we have a performance test class. We've got a regression tests class. We've got a feature 1 tests, the bunch of tests here, and feature 2 tests. Okay, so these are the 4 test suites that we've got. And also recall from the previous lesson that I've defined a my test suite here, which included all of these 4 test classes, as you can see here. Okay, and then there was a my super suite test, which I used to demo a suite that includes a suite, which I called my super suite. And then I also recall that then after these 2 suites were defined, my test suite and my super suite, then we start using categories to filter out test classes. So let's start by converting all of these test classes and suites and categories using tag annotation. Okay, so the first thing we're going to do is we're going to see how we can convert or implement this my test suite. So recall that in JUnit 5 there is no concept of suites anymore. This has been discontinued. So now the only extension model, as mentioned on the previous lesson, is with the extend with. If you want to use the JUnit 4 test suites, there is a way to use them using the Run with JUnit platform. But the issue is that this is technically not really a JUnit 5 test anymore, so I don't want to cover that in this video. What I want to show you is how just to use tags we can achieve the same functionality. Okay, so the first thing we're going to do is let's convert all of these categories with tags. So basically what you need to do is you just need to replace category with the word tag, okay, which is how it's defined in the Jupyter API, and then we define the name of the tag with just strings. Okay, so we're going to have this tag. Let's copy this. So we're going to have a flaky tests tag here. Okay, and we're going to have a feature tests tag. Okay, so we have flaky tests tag and feature tests tag, which corresponds to the categories tag that we had before. This is that for, let me expand this because there is something wrong here, and let's fix this. Let's also make all of the access package private. Okay, so as a way to clean up the class. Alright, so that's that for this class. Now let's go to feature 2 tests and do exactly the same thing. So let's replace the category with the tag, and this tag is going to be called feature tests. Okay, so that's one. Let's just remove this and import this. Good. And let's fix again the package access. Let's make everything package private as per the JUnit 5 mechanism, and recall that this class here, let me make this thing slightly bigger, that here we have 2 tags. In this example we had a tag applied to the class level, and we also had a tag applied at the test method level, which we called flaky tests. So remember that the tag notation is pretty much the same, has the same concept and applicability as the category. So you can apply it at the class level, like here, or you can also apply it at the test method level, like here. So this class has been converted to JUnit 5 as well as this. So let's keep going. So we had the regression tests class here. Let's just clean this import and convert this to the Jupyter API. And again, let's make everything package private. And let's also create a tag here for the regression tests. Okay, so now let's do the same thing for the performance tests. Let's create a, let's first fix this class. So let's import here and let's make this package private, and so all of them. And let's also create a tag here called performance tests. So now we have regression tests, performance tests, and all of the, basically all of the test classes have been converted to the Jupyter API and are using the tag annotation as opposed to the categories. Okay, so now let's work with the suites and the categories for filtering. So as I mentioned, suites are not natively supported in JUnit 5 any longer. So, you know, we can't do this declaratively in JUnit 5 any longer. So what we're going to have to do is we're going to basically have to specify this suite in a Gradle. In our Gradle build, which is the example I'm using. If you're using Maven, is pretty much the same, very similar mechanism. So let's see how we can define this test suite in Gradle. So let me get my Gradle build and let's see how we can fix this. First, let's clean up this a little bit here. Okay, so one thing that I would like to mention before we actually set up the Gradle test suite here is that there are a few rules that you need to follow for the tag names, this string. You know, there are some reserved characters that you should not use here, like commas, left parentheses, right parentheses, ampersand, vertical bar, and exclamation point. The vertical bar is basically the pipe. So basically you're restricted to printable characters with the exception of the ones I mentioned. You cannot use control characters and you cannot have white spaces here. Okay, so let's go back to our Gradle build here and see how we can specify test suites. So the first thing we're going to do is define the equivalent of my test suite here. So recall that my test suite is basically including these 4 tests. So the way to do it in JUnit 5 with Gradle support is to use the include tags method. And basically what we do is we just basically create a list here of all of our tags that we define. So because we're including feature 1 tests and feature 2 tests, there are 2 ways. One is we can just include the feature tests, which notice that we tag both the feature 2 test and the feature 1 test, or we can include individually. Let's actually do both ways. So the first one is, like I said, we're going to do feature 1 test followed by feature 2 test. Then we're going to include the integration test, which I've got here, and lastly performance test. So this is the equivalent of let me just expand this a little bit here. So this would be the equivalent way of defining this my test suite in JUnit 5. This is how you define it. Okay, so now that we define this, let's move on to the next one. So the next is my super suite, and as you can see, this is basically just my test suite with one additional test class, regression tests. So obviously, let me just add here some comment here, equivalent to JUnit 4 and equivalent to my super suite. My super test suite, I should say, is basically just adding the regression test. Just comment that because we're going to run this guy here, and let's keep going defining all of my test suites. So the next one, recall, is the one that we are defining all of the feature tests, excluding the flaky tests. So here there are two ways to define this. So first let me just put a comment here. So this is equivalent to this, and we can define it with include tags. And here we're going to use a Boolean expression. So the include tags supports here a Boolean expression of tags, as well as parentheses if to change the precedence order. So you can do, I'm going to define the feature test, and I'm going to exclude the flaky tests tag. Not. So the operators that are supported are the not, which is the exclamation point or bang, the and, which is a single and %, and the pipe, which is an or. And also you can use the open and close parentheses for to change the precedence, which is left to right. So we can define the include tags like that for the all feature tests without flaky tests. Another way we can define it is by using the exclude tags. So I can say include tags, and there is another method here called exclude tags, and I basically can say include the feature test tags and exclude the flaky tests. Okay, so this would be equivalent to this way, but I prefer this way because it's just more compact. Okay, so moving on, let's define the next filter. So we have all but flaky test suites. So this is essentially all of the tests that we had defined up here. So we're going to include all of these tests, and we're going to exclude flaky tests. Sorry, actually this is all but flaky tests. So what else we have here? And then we have the flaky test suite, very similar to these guys. So let's copy that. Let's remove this, and basically we want the feature tests and the flaky tests. So this is basically what we want. Okay, so that's basically how in JUnit 5, using a Gradle project, you would filter the use the tag mechanism to organize and group tests, and then the Boolean operators here, along with include and exclude tags in Gradle to do the equivalent of the categories and include and exclude categories in JUnit 4. Okay, so now that we have all of our Gradle configuration here, let's just get rid of all of these JUnit 4 test suites and categories so that we have a clean build, and let's test each of these suites in turn. So let's clean the project here. Okay, so let's take a look at this thing here. So notice that feature 1, all of the 3 tests of feature 1 test, all of the 3 tests of feature 2 test, and all of the 3 tests of integration test, and all of the 3 tests of performance test have, we got the runs for all of them. So this was equivalent to my test suite. So let's comment this out and let's uncomment these. And this is basically, modeling or mimicking the my super test suite, which is basically the my test suite with regression tests. So let's run this. Okay, so we see that all of the tests ran, and we got our next extra run here, which is the regression test. One thing I need to mention here is that it's not possible to control, unlike on a JUnit 4 test suite, the order of the tests. So for example, if I change, let's say I want my performance test and regression tests to run before my feature tests, for instance, just sake of example here. So notice that the tests are still running in this order, which seems to be, just alphabetical order. So there is no way to, as far as I know, to actually change the order of the that you could do in a suite. So moving on here, the next one was where I'm running all of my feature tests, excluding the flaky tests. Okay. So let's run this and see what we get. So notice that the feature 1, all of the tests in feature 1 have been excluded because this entire class is being tagged with flaky tests. Feature 2 test, we've got only the class itself, it's not tagged with flaky test, but one of the tests is tagged with a flaky test, test3. So of these two tests, only the tests from feature 2 test 1 and 2 should be included. Okay, moving on, let's define the suite or category equivalent to all but flaky test suite. So let's run this and see what we get. Okay, so the first thing you notice that all of the tests in feature 1 have been excluded because this entire class is tagged with the flaky test, so they don't appear here. And feature 2 tests, only the 1 and 2 is included because test 3 here of the feature 2 test is tagged as a flaky test. And if you look at the rest of the 3 classes, you see the 3 tests here, 3 tests here, and 3 tests and 1 test here, because all of this integration test is not tagged anywhere with flaky test. Performance test also, it's not tagged with the flaky test. And regression test, if I show you here, has only 1 test. That is not tagged with flaky test, hence it's included. Okay, so continue. Lastly, I think this is the last guy here. This is where I had a in JUnit 4 a flaky test suite that included only flaky tests. So if I run this guy, I should be able to see all of the tests in feature 1 test because it's tagged with flaky test. Okay, so all of the 3 tests and a single test in the feature 2 test, which is this guy here. Okay, so this concludes this lesson. I hope you found it useful. Thanks for watching. In this video, I'm going to show you how to use the new assert all assertion in the Jupyter API. So I've got here an example where I have an exchange, which is my component under test. And what I can do with this exchange object is send orders. So notice that I send an order and it takes obviously an order. And then if this order is accepted as per the stock exchange rules, then I get a trade. So in this very simplified example, what I want to do is I want to submit an order to the stock exchange and I'm going to get a trade. And what I want to do is that this trade matches the order that I submitted. So the order is basically a container of the direction, which is buy or sell. A symbol is just a stock symbol, and a price that I want to, the max price that I want to buy or sell. If I'm buying, it's the max price. If I sell, it's the minimum price, and the quantity of the stocks that I want to buy or sell. So and then I get a trade, like I said, which matches this order. So this is in this particular example, I'm submitting an order to buy 100 shares of IBM at most $42. In JUnit 4, I would invoke the method that I want to test, which returns a trade object, and then I want to assert that this trade object is in this particular state. So I'm going to assert the direction, the symbol, the price, and the quantity against the expected values. So if I just run this, then if I run this test, then obviously all is good and all passes and so on. However, if, for example, just for the sake of the example here, let's say that for whatever reason I'm expecting Apple, then what I want to show you here is that and you know what, let me just make another assertion here, a failure, to illustrate what happens here. So notice that I have 2 assertion failures here. I have an assertion failure here that the symbol obviously is IBM and I'm expecting Apple, and the 4th assertion, the quantity of the trade is actually 100, but I'm expecting 10. However, when I run this test, only 1 error is reported, which is okay. It's what you would expect in JUnit 4. In other words, as soon as the first assertion fails, then the test is aborted and you get an assertion error for this assertion that failed. But what if what you want to do actually is you want to assert the complete state of the object, and then at the end you want to be notified not just about the first assertion failure, but the complete set of assertions that failed. So this is where assert all helps in JUnit 5 with the Jupyter API. So in the Jupyter API, the assert all assertion has been introduced precisely for this very same case. So what happens here, when you group all your assertions here, I'm grouping all of these assertions into an assert all assertion. What happens is the entire assertions, all of these four, will be executed regardless of whether there are failures or not, and at the end in this group assertion with assert all you will see the complete set of state of your object. So let's run this case now, just the one that passes, just to validate that we have the same behavior. So everything passes, but now let's do the exact same thing that we did for the previous example, i.e. where there is an assertion failure on the symbol as well as the quantity. And unlike the previous example where we were only notified about the first assertion failure, here we're going to be notified about the full assertion failures. So the two assertion failures in this case. So notice that we have the assertion failure for the symbol, but we also have the assertion failure for the trade quantity. Okay, so we got two assertion failures, and we have a very useful here stack trace for the first assertion and for the second assertion. So moving on here, if you do want a behavior which is similar to JUnit 4, where you, for whatever reason, you want to have a dependency between the execution of the assertions, that is, you only want to execute one assertion if the previous one or all the previous one pass, then what you would do is, instead of doing it putting all of your individual assertions inside a single assert all, what you would do is you would put the assertions inside a code block. Okay, so you use this lambda on a code block, and inside here you put all your assertions. Then in this particular case, the difference between this assert all with a code block as opposed to this one that doesn't have a code block is that here there is a dependency on the previous assertions passed to execute the next one. So assert all here will only be executed if this assertion passes, and obviously because I'm asserting that false is this condition is true, then clearly this group assertion will never execute. Another thing that you can obviously see here is that I can deeply nest the assertions or group of assertions. So assert all here is taking a lambda that provides assertions, and one of them actually is an assert all, and I could just do multiple levels of deep nested of group assertion. So let's run this example and see what we'll get. And like I said, obviously the only thing that should happen is I should just get one assertion failure, and that's it, and the test should just basically abort, and the next group assertion should not run. Finally, if you want to have independent, you still want to have the group assertions, but without dependencies between the execution of assertions inside the assert all, then the only thing you need to do is, instead of using a code block, just use individual group of assertions, and all of them will be executed individually. So let's run this. So notice what's happening here. I've got, in this first group of assertions, I've got one assertion failure at the direction here, which is reported here, and subsequently I have another assertion failure here because obviously false is not true. So that's pretty much the power of the assert all in the Jupyter API. like I said, it enables you to group assertions and to just at once in one single assert test the state of an object. You can group assertions and create deeply nested levels of group of assertions that contain group of assertions that contain group of assertions, and create dependencies between them or execute them independently, like in this case, or here where you have a dependency. This only executes if the previous one passes because it's inside the code block. And obviously, you can just continue using the JUnit 4 style of assertions. So I hope you found this video useful on the power of the new assert all in the Jupyter API. This is Nilton from Craft of Programming. Thanks for watching. Hi, this is Nilton from craftofprogramming.com, and in this video I'm going to show you how to convert an existing JUnit 4 test to compile and run against the Jupyter API, which is the new API in JUnit 5. So if you recall from the previous lesson, when I introduced the basic fundamental assertions in JUnit 4, I used this book DAO test, so I'm basically reusing it here. And as you can see, there are a lot of compilation errors, because this IntelliJ Java project has already been, the dependencies have already changed to JUnit 5. So notice here that I already have a dependency with Jupyter API, as well as the so this is a compile time dependency, and the dependency with the engine, the Jupyter engine, is a runtime dependency, and there is also a Hamcrust library dependency here. So this is a JUnit 5 compile and runtime dependency. So we have now to convert this test to the Jupyter API. So the before class annotation has been changed to before all. The after class annotation has been changed to after all. The before annotation has been changed to before each, and the after annotation has been changed to after each. Okay, so these are basically the four fundamental changes in terms of annotations. So the ignore annotation has been changed to disabled, and it still takes a string. Let's import this. Import static method. Good, so we're almost there. Fix this. And let's continue. And let's just remove all of these annotations, as well as these annotation, and all of these imports. So we're almost there. We still have a the import here for the test annotation. Notice that all of the main annotations of main lifecycle annotations, to say, have been moved to the Jupyter API. So before all, before each, and disable, and so on. So all of these have been moved to the Jupyter API package, and all of the assertions have been moved to the Jupyter API under the assertions package as well. All of them are here. Okay. So let's continue here and see. There is only one last thing we need to do, which is the assertion argument here. If you look at the parameter, notice that the order of arguments here has changed. So the argument of has moved to the last argument. Okay, and this is actually now a supplier, a string supplier. So let's do it as such, and that is basically that. So now we're almost there. We fixed pretty much all of the tests, all of the compilation errors. Another thing we can do is IntelliJ is actually telling us that we can make this package private. So let's basically fix everything here. So at once we made the test class a package private, as well as all of the methods, as you can see. So all of the lifecycle methods, as well as test methods, have been made package private. Okay, now that we converted the project to the Jupyter API, let's run and make sure that it still works. So as you can see, all of the test still runs, and with all of the test methods working as expected. I hope you found this video useful on how to convert a simple JUnit 4 against the Jupyter API of JUnit 5. Thanks for watching. In this video, I'm going to show you the limited support that JUnit 5 adds for JUnit 4 rules. So the support in JUnit 5 for JUnit 4 rules is quite limited, and pretty much only these 3 rules are supported. And the way to add support for them is you need to basically add the JUnit-Jupyter-migration support, dependency to your JUnit 5 tests, and then you have to tag the test with the enable rule migration support. And then if you do this, if you add this dependency and then you tag your JUnit 4 tests with this tag, then you can continue using the temp folder, the expected exception, and the error collector, as well as the external resource rules from JUnit 4. So this is the mechanism that JUnit 5 has for limited backwards compatibility of JUnit 4 rules. What I am showing you here is that, just show you that this still works. You can still use the temp folder rule as I'm showing you here. This is a very basic case where I just create a temp file and assert that it exists. And I'm using the old, JUnit 4 style of using a rule to test for a code that throws exceptions here in this example, and using the error collector example here. And also I'm showing you here an example where I am using the external resource rule. So if I run this test, let's see what I get. So the test temp folder rule still works, so it passes. The temp folder rule creates a temp file and asserts that it exists. The JUnit 4 exception style test also works, and the test error collector, it's also working because I'm basically being notified of two exceptions, the first one where I collect here and the second one. So notice here is the array index out of bounds exception and the null pointer exception. So that still works, and the external resource rule also still works. That's basically the mechanism of backwards compatibility support of JUnit 5. It's limited. This is just supposed to be used to ease the migration from JUnit 4 to JUnit 5, and I believe it's an experimental feature. So I hope you found this video useful. This is Nilton from craftofprogramming.com. Thanks for watching. In this video, I'm going to show you how to convert the JUnit 4 exceptions, all of these 3 ways that in JUnit 4 are quite common to check for exceptions in JUnit tests, to the new JUnit 5 consolidated unified way to test exceptions. So the reason why you're seeing this JUnit 4 exception test in error is because I've already converted this JUnit 4 IntelliJ project to use the Jupyter API, and that's why you're seeing that this is in error. So what we're going to do in this very short video tutorial is basically to convert these 3 ways into the single consolidated way to test exceptions in JUnit 5. So essentially, all of these 3 ways to test exceptions. So let's just put here, this is basically JUnit 4 way to test, and in the previous lesson I covered that. In JUnit 5, basically, everything is just tested with, there is only one way, which is a third throws, right? And this basically takes an exception class, and there is here a lambda, basically is the supplier of the method that you're testing, and then this guy here gives you back an exception, and And that's pretty much it. And then you use this exception on an assertion. For example, assert equals, and then you use this guy. You can get the message and you can do whatever you want with it. Typically you want to assert that, error message here that this exception throws, basically matches something here, right? So that's pretty much the idiom, unified single way of testing exceptions, JUnit 5. This method here, if you recall, we are basically calling a method here which doesn't throw an exception, and then one that throws. And then what I was highlighting here is that there is no way in this way of JUnit 4 to basically get the exception message back. So anyway, this is not the way to do it anymore. So anyway, what you need to do is you just do assert throws. You put the exception that you're expecting. So I'm expecting an array index out of bounds exception. And I will basically here put my supplier, which is, yeah. So my method supplier here will be basically these two. Let me import this. And now I can get the exception back. So this is basically my exception. And then, I mean, I don't really need the entire, that specific exception type. So now that we have the exception, we can just write a our assertion like we usually do. So we're going to assert that this the actual message contains the string, so basically the exception type here. And that's it. So that's pretty much how in JUnit 5 you test for exceptions. So all of these ways that were competing ways of testing exceptions in JUnit 4 have been consolidated into a single way of testing exceptions. I hope you found this video useful. Thanks for watching. In this video I'm going to show you how to rewrite the test name rule that is available in the JUnit 4 in JUnit 5 using the Jupyter API. So the test name rule is not supported any longer in JUnit 4, and this is how you would use it. You would declare it, and basically in your test method you would use the rule to give you the method name. So this is not supported anymore. So how would you do the same thing in a JUnit 5 using the Jupyter API? Well, the way to do it is using the test info object. So your test methods are overloaded with the test info, and this test info object that is passed into your test method, as well as the constructor as I showed you here, and a lifecycle method like before each or after each and so on, are parameterized or overloaded the test info, and this test info object gives you the name of the, or the display name I should say, of the test, and we will see how to change these or specify these. It gives you the tags that you may be using in your tests, as well as the containing test class and a the method object using reflection. So for this example I'm going to focus on the get tags and the display name. The test class itself has a display name. This is what, when you run the test, that's what's going to be displayed. Okay, and in the constructor for this test name class, like I said, we're using here dependency injection. We have the test info passed in to us, and we can then assert its display. We have access to the display name through the test info object, and because this is the constructor, the test info itself it's going to, when you call display name, is going to give us the name of the test class. Conversely, on a test method, when I call display name, it's obviously going to give me the name of the test itself. So this test one, its display name is always going to be my test, as I am asserting here. Notice that in this example I'm also using the test info get tags to get access to the tag that I'm specifying here. And another nice thing about this test info is that if I use it on a lifecycle method like before each, which recall is invoked before each test method is invoked, then I get access to either the myTest or the foo method, because remember, this is going to be called before test1, and when it's called before test1, the test info will have information about the test1 test method. And when it is invoked before the foo test, then the test info will have the contextual information of the foo test. So let's run this and see how this is displayed in the output. So notice that foo is displayed as foo because I didn't change its display name. However, my test, which is the second test, instead of displaying as test1, is displayed as my test. Also notice that the entire name of the test itself has been also renamed from test name replacement to JUnit 5 test name replacement. And obviously all of the assertions that I have here passed. What happens if I add another tag? So for example, I have my tag 1, I can have other tags, my tag 2, and obviously, test info here, because this returns a set, then I will have my tag 1 inside the test info as well as my tag 2. Okay, so if I run this, then my expectation is that this will pass. Alright, okay, so I hope you found this video useful on how to replace the use of the test name rule in JUnit 5 using the Jupyter API. This is Nilton from craftofprogramming.com. Thanks for watching. In this lesson, we're going to cover JUnit 5 parameterized tests. In the previous lesson, I already covered JUnit 4 parameterized tests. This lesson is going to cover exclusively parameterized tests using the Jupyter API. What we're going to cover in this video is the @ValueSource annotation. This annotation is used to inject a parameter or list of parameters to a method, a test method that has takes a single argument or parameter. We're going to cover the null source, empty source, or the null and empty source, which is an annotation used to inject, as the name implies, null values or empty values. And we're going to see which types are covered by this annotation. We're going to cover the @enum source, which is used to, as the name implies, to inject or to pass in values to test method that takes enum. We're going to use the method source, which effectively, as you see, supports single and multiple argument injection via a factory method. Then we're going to cover CSV source, which, as the name implies, enables you to specify a list of CSV comma-separated values onto your test method, and you can either do it explicitly in code, or you can load these CSV files from a file. And we're going to see how we can specify aggregate values as opposed to individual values, and also the some facilities that the Jupyter API supports in terms of conversion, especially from strings to any of the primitives and collections or arrays types in Java. There are a few advanced features that we're not going to cover, which is the argument source, convert with, and aggregated with, or aggregate with. These are, in a way, corner cases, or not so used features, which for an introductory tutorial on JUnit 5, I didn't feel that it made sense to include them here. Okay, so let's now start with the basics, which is value source. So the value source, basically, as I mentioned, is used for test methods that take a single argument, and you can specify an array of literal values of type primitives. Any of the primitives is supported, so you can specify ints here, or string, or bytes, or longs, or doubles. you can also specify a class, the class type. So the way you basically tag a test method as a parameterized test method is using the @parameterized test annotation. And this name here that I'm putting is optional. So you don't have to specify it. It's recommended to specify it so that when you run the test, you have a more descriptive test name in the output that you can refer to. The index is basically the account of the test's invocation, and then you've got, just like in JUnit 4, these placeholders which are going to be expanded with the actual value or the actual parameter that you are injecting. So because the value source this method only takes a single argument, then it only makes sense to use one single index. And what I'm doing here is something very simple. I'm basically injecting a symbol out of this provided by this list, and then I'm just asserting that that this symbol, it's actually one of these guys here. So let's run this and see what we get. So as you see, the test passed, and notice that how the output is being formatted because I'm using the name. So I've got the index 1, 2, 3, and then the actual placeholder here is being expanded by the actual value of the parameter that I'm passing to the method, IBM, Apple, and Google, and the assertion is passing. I mean, like I said, this is not mandatory. If I don't specify this and I just run the test, then obviously I'm going to have the default name that JUnit provides, just like that. So you can specify ints like that, and obviously the type here would have to match, and so on, or any of the other primitive types. So moving on, let's cover the null and empty source annotation. So as mentioned, the null and empty source is a convenient annotation which basically aggregates the behavior of the null source and the empty source. So in other words, this writing null and empty source is exactly the same thing as putting a null source and the empty source. So this would be equivalent, but obviously, if you want the behavior of both, then they just provide this notation as a convenience. And anyway, null and empty source is useful when you have a test method that accepts either a string or a collection or an array. So this is not suitable for primitive parameter types. And you would want to test boundary conditions where if I pass a null, what happens, or if I pass an empty string, what happens, right? That's how this is convenient and useful, right? So let's run this and see what happens. So notice that my null, empty, and blank string test method got passed a null and empty string. If you want to extend these parameters beyond the null and empty string, then you can also use the value source in addition to null and empty source and provide more values here, where you have a blank string with spaces and tabs and a null character. So again, if I run these, obviously now I'm going to have 6 test method invocations with all of these values. So moving on, the next annotation is @enum source, and this annotation is useful for test methods that accept, like the name implies, an enum. And the most simple case that you have is you have your parameterized test, and an enum source, you specify the enum, and in your test that accepts the enum, you basically are passed all of the possible values of that enum, and then you do whatever you want to do with it. So in this particular case, the direction for the trade, it's a buy, sell, or hidden. Hidden is in case you don't want to reveal whether you're buying or selling. And because this direction enum contains 3 values, then this method, I'm going to have 3 invocations of this method, each for one of these values of this enum. So if I run this, then I have the 3 invocations, one for each of the enum values. If for whatever reason you don't want that behavior, you want to restrict the of enum values that you want to pass into the method, then it's very simple. The only thing you need to do is you basically have in the enum source, you specify explicit names of the enums that you want to pass. So if you now run this, then notice that instead of having all of the possible enums invocations of this method, I just have a single invocation of this name. An equivalent way to do that is to actually exclude, there is another parameter here called mode, which you can exclude the values that you don't want to run. So because this enum contains by, cell, and hidden, then this method and this method are completely, obviously equivalent. Just for the sake of completeness here, there is another mode here called match all. And this match all mode for enum, a parameter injection, is basically in cases where you want to specify a regex, for instance. So, for example, I could say here something again that will be completely equivalent is say an enum that, for example, starts with, for example, the letter B, for instance, and then takes anything. So if I run this, then notice that this is completely equivalent. All right. Okay, so that's enum source. Moving on, there is another nice feature of the parameterized tests, which is argument conversion. There is a table of conversions. Let me show you here. So as you can see in this table, this is how pretty much all of the strings are converted to the corresponding types. If you specify a true, string literal, it's converted to this true value, and all of these values for either the primitives or the corresponding boxing values, and so on. If you specify a path to a string literal with a path to a file, and your test method contains a file, then this string literal will be converted to a file object, that path. And for example, you have more interesting cases here, like you can convert a string literal containing a date to a local date object, and so on and so forth. So please refer to this table for the complete built-in automatic conversion of strings to Java parameter types. So in this simple case here, what I'm doing is I'm converting this string to this enum, and obviously it has to match. So if I run this, then notice that it works. So there was an implicit conversion of this string to this enum. So as you can see, another example here using a string literal that represents a date, and there is another example where you can convert this to a local date. Okay, this is another example. Okay, so moving on, let's cover the method source. So as I mentioned, the method source is a way to pass or inject a parameter utilizing a factory method. So there are some rules for the factory methods. Basically, the factory methods must be static, a no argument method. And this factory method can be inside the same test class as the test method, or the factory method can be on another class. So let's run this to make sure that it works. So notice that this test method that takes a symbol is using this symbol provider factory method, and this symbol provider factory method is generating on the fly these three values. And notice that for each of these values I get one invocation of my parameter test. You don't have to explicitly set the name of the factory method. If you don't specify it, for example, if I don't specify the factory method, then the Jupyter API will implicitly look for, in the same class, a factory method, a static factory method that matches the name of your test method. So this will be completely equivalent. Let's run to make sure that it still works. As long as you have a factory method, a static factory method that matches the name of the method, then you don't have to explicitly specify here. But I prefer to be explicit and specified here, which is particularly important if I have, multiple factory methods. And it's probably very easy. You come here, you rename the test method, and then you forgot to rename the factory method, and then suddenly things break and you don't know why. So it's better to be explicit. Also, like I mentioned, if you have multiple test methods utilizing a factory method, possibly these test methods may be in different classes, then it makes sense to externalize the factory method on a different class. So what happens if instead of passing only a single argument, you want to you have a test that takes multiple arguments? So what you would do is you would have to use a collection of arguments, and this is either an actual Java collection, or a stream or an array of arguments objects. Okay, so in this particular case, I am passing in a list of parameters here, from which I'm going to construct an order object to send to my exchange, which then gives me a trade that I can do something with it. And recall that the order object is a container for a direction, which is either buy or sell, for a symbol, which is the representation of a symbol on the stock exchange. This could be an Apple, Google, IBM, whatever, a price that I want to trade, and the number of shares that I'm interested in trading. So if I want to test these, then I would create my test method with the list of parameters here that represent from which I construct an order object. And if I'm using a method source with a static factory method, because I'm passing in a list of parameters, then I need to use a stream of arguments, or a collection of arguments, or an array of arguments. In this case, I'm using a stream. And basically, the stream takes the arguments, which is a static factory method in the arguments interface. And with this, I basically pass in all of the arguments that match the signature of my method here. Now notice one thing that is really cool here. Because I'm using a factory method, right, then I can generate at runtime dynamically the arguments to pass to my test method. So in this particular case, I'm creating a random price, right, up until 250, and also a random quantity bounded by 400. So let's run this and see what we get. I can see here the values that are being passed to each of the 4 invocations of my method. So if you have static values, just use a CSV source, and it's a very convenient way to specify all the possible values at compile time for your method. If I run this test again, I'm going to have 4 invocations of my test method, each per line here, right, as I'm specifying here. One issue that you may have with having this large parameter list here is that this might start to be a little bit hard to understand or read or maintain, right? So for that particular reason, JUnit provides this arguments accessor interface, which your tests automatically are injected with if you want. So instead of having this long parameter list, you can basically use an argument accessor, and with the same CSV source annotation to pass in the full set of values to your test method, you basically using the argument accessor, you can inside your test method, you have basically these getters which match the type of the value that you want, and there is automatically conversion from these values to what you want. So, and they start at 0. And I would argue that this is a more convenient way than doing it like that. So again, if I run this, then notice that it passes, and it's pretty much the same output as you would expect as here. So another way that you can do the exact same thing is, instead of using a CSV source, especially you can see that this would be completely unmaintainable and really hard if this is a very, very large list of parameters that you want to inject. So for that purpose, there is the add CSV file source, which, as the name implies, enables you to read the CSV off of a file as opposed to from the test itself. The only thing you need to make sure is that this file is on your runtime class path. Just like before, notice that it's exactly the same thing. I have the header of my CSV and I have my 4 values here that match the direction symbol, price and quantity, and I have here a nice way to skip the the first line because I don't want to load the header. So if I run this, then notice that I get the exact same value as I did for this case. So we have covered all of the ways that you will utilize parameterized tests most of the cases. I hope you found this video useful.